iso and oro both are present. Okay.
And what is roll number of two? Roll number 1 or 2? Aru?
No, sir. No, ma'am. Auditor is roll number 1.
Auditor is 1. Okay, okay. Auditor is 1, roll number 1, and you is roll number 2. Okay. And the and your copy and all now right now completed. Your copy
You
and
are
all.
not copy and lab manual.
Yes.
Yes, I was showing to sir.
Yes. Okay. Okay. Now, what are the experiments actually you have completed?
Yes, ma'am.
What are the experiments?
1, 2, 3, and 5.
1, 2, 3, and 5. And what is the objective of experiment number 1?
Objective is to find the what to say uh, uh, determination of acid value of vegetable fatty oil.
Vegetable fatty oil. Determination of acid value of vegetable fatty oil. Okay.
Yes.
Then what is the meaning of vegetable fatty oil?
Vegetable it means the amount of free acid present in the oil.
Free acid means how many types of acids?
Organic acid and what or inorganic.
Organic acid and inorganic acid. In fatty acid, what type of acid present?
Organic.
Organic acid. Okay. Now, why you tell me that vegetable fatty acid?
Huh? Vegetable
Why you tell me the vegetable fatty?
because it
What
contains
is the
some
meaning? Vegetable.
because the vegetable oils contain some fatty is made up of fatty acid. That's why every oil and fat is made up of that fatty acid.
Now, what is the composition of fatty acid?
Composition of fatty acid. It contains a COH group, carbon, hydrogen, and oxygen. They are made up of.
Carboxylic group. It contains some carboxylic acid, carboxylic
Yes.
group. Okay. Acha. Then carboxylic is dibasic or monobasic?
Carboxylic is dibasic or monobasic. It's
Fatty acid is
monobasic.
fatty acid.
Monobasic. Monobasic.
Monobasic. Monobasic. Okay. If it is sulfuric acid, then
It's a dibasic.
yes, this is dibasic acid. Okay. Then how you determine the fatty acid in your vegetable oil? What is the procedure?
It can be determined by the potassium hydroxide method. That is the number of milligram of potassium hydroxide needed to neutralize the free acid present in 1 gram of the fat or oil.
1 gram.
1 gram of
That
oil or
means
fat.
your unit is milligram per gram.
Yes, ma'am.
Am I right? It
Yes,
is
sir.
milligram
Amen.
per gram. Yes. Now, uh, tell me, what are the reagents used to determine the fatty acid in your vegetable oil? What are the reagents?
Reagent ethyl alcohol, diethyl ether, phenolphthalein, phenolphthalein, and water.
Which solution?
Yes.
Oxalic acid.
Oxalic acid. Auditro, first I ask some questions, Audo, then after that you give me answer when I ask you. Okay? Then, Audo, will,
Excuse me,
the,
ma'am. Good
yes,
morning, ma'am. Ma'am, will we tell who would get the answer first? Will tell it or like roll number wise?
no, roll number. First I ask Audo, and after that
Okay,
you
okay,
come. Okay? Okay.
okay.
Acha. Now, Audo, tell me, wow, what are the chemicals you use?
Chemicals?
Chemicals you used in this
KOH,
experiment.
KOH solution, oxalic acid solution,
KO8 is your chemical, KO8 solution is your reagent.
ethyl alcohol, diethyl ether, phenolphthalein. This,
These are the chemicals.
yes,
Acha.
ma'am.
Okay, why you use oxalic acid in this reaction?
Because we are going to determine the fatty what to say acid value of that only.
Oxalic acid. Auditro, can you
Yes,
tell
ma'am.
me
Yes, ma'am.
why?
Because KH is the secondary standard solution to standard
Yes,
fluid solution, we use
yes,
oxalic acid.
oxalic acid. We use oxalic acid. Then what is primary standard solution? What is the definition?
I mean, ma'am, uh, ma'am, এটা জানি না।
Oh, তুমি জানো না। আচ্ছা, okay. Then how you prepared your oxalic acid solution?
Mm,
Who will tell me or Aditya?
Auditro.
The 25 ml oxalic acid solution
No,
by
no, no.
prepared
How you
and
prepare the primary standard solution? What is the
huh?
procedure? What is the procedure to prepare the primary standard solution?
Mm,
How you prepare oxalic acid? What is your required amount? If you
20,
want to prepare n by 10 solution,
huh.
if you want to prepare n by 10 100 ml solution, 100 ml volumetric flux you use to prepare the oxalic acid solution and the strength is n by 10. Then what is your required amount?
So oxalic acid 125 gram molar mass,
No, 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 no,
equivalent
no,
of
125, not 125.
126 gram,
Yes, 126.
6 gram, equivalent mass 63 gram, and the
Huh?
requirement 0.63 gram.
Yes.
So,
0.63 your
gram.
required weight. Okay. Then you just volume make up to the mark of your volumetric flux.
Hmm.
Okay.
Hmm.
Then why you use the phenolphthalein to determine the strength of your secondary standard solution?
Why is phenolphthalein?
Phenolphthalein.
Because phenolphthalein is a indicator, uh,
Huh?
to neutralize when the solution is neutralized. Is indicate.
Yes. Yes. That means you want to indicate the equivalence point. You want to indicate the equivalence point,
Yes.
and that is why we use the phenolphthalein
Phenolphthalein.
as an indicator. Okay. Now, yeah, phenolphthalein is what type of indicator?
Mm. What type of meaning, ma'am?
What type and how many type of indicator?
Ma'am, but its pH was 8.2 to 10. Its
No,
pH.
that is your action area. But the classification of indicator, there are two type of indicator. Then phenolphthalein is what type of indicator? Okay. Then what is the color of indicate phenolphthalein in your acid?
Light pink. Light pink, ma'am.
Why?
And
My question is that why in acid medium the color of the phenolphthalein indicator is going to be light pink? How it is possible? What's the pH range? You know this is a an acid base indicator by its color change, we understand actually, okay. So what's the stage of titration in acid base titration? So naturally, it must have some pH range.
Hmm.
So phenolphthalein indicator, do you feel that? Do you know that it gives pink color in acid medium? For example, I'm telling you, in the conical flask, suppose you have pipetted out 25-meter oxalic acid, okay,
Hmm.
and to which you are adding nearly 2 drops of phenolphthalein indicator. So at that moment, will you see the color change becomes pink? Yes or no? Hello?
No, sir. No, sir.
Then, so in acid medium, definitely it is not becoming pink. And suppose in the burette, for example, if it is either KOE solution or NOE solution, okay. Now you are adding slowly by setting the conical flask, okay.
Okay.
Then at the end point, what do you observe? What will be the
The
color change?
the color was light pink.
Then why? Then that means the light pink is coming. The color of the phenolphthalein indicator when it is becoming alkaline. That means pH is, should be above 8 or so. So how this
8.4 to
is
10.
then okay, okay, it's all right. You now just try to fill up the Google form, okay, as per your roll number.
Okay.
You can complete that, and within 12:45 you just submit it. Acha, next, Oro,
Can I leave?
madam. Yes, yes, you can leave.
Yes, sir.
Uh, Oro, how many experiment you have done? Virtual lab you have done. You have attended.
So 4.
Oh, okay. Can you mention those virtual lab? What are the names
Uh,
of the experiments?
determination of acid value
Mhm.
of vegetable fatty oil, and by mole method determination of
सर सर एक मिनट और हो स्विच ऑन
yes
योर
ma'am.
वीडियो स्विच ऑन योर वीडियो
Or switch on your video. That is the most important. Yeah, right.
By Morse method determination of dissolved oxygen, and by modified Winkler's method determination of water sample, and by
For what? By Winkler's method, what do you estimate?
by ideometric method.
Now, what do you estimate actually of the water sample by Winkler's method?
Dissolve
Dissolved
oxygen.
oxygen. And what about another experiment?
Yeah.
Just you open your lab manual, check with that, verify with that.
Partition coefficient of acetic acid between water and butane 1 mole.
Okay. The one thing I would like to know from you that as far as the determination or estimation of dissolved oxygen in a given water sample. So first of all, what do you understand by dissolved oxygen?
It is
What is
the
it?
amount. It means that the amount of water dissolved in amount of oxygen dissolved in the present water sample, not chemically, but it is
Okay.
this.
One thing I would like to know: does it obey Henry's law? Yes or no?
Yes, it must.
Acha, okay. Next thing I would like to know from you that as far as the dissolved oxygen is concerned, what is its significance? So what should be in general the saturation level of expected saturation level of dissolved oxygen in water? Suppose around between 25 to 30 degrees Celsius in that range. What do you expect that what should be the saturation level of dissolved oxygen in water?
So I don't.
Do you understand my question? What I'm asking? I am asking what do you expect that saturation level of dissolved oxygen in a given water sample, suppose at a temperature range of 25 to 30 degrees Celsius.
Oh, not the value. It was asking for the.
Yeah, yeah.
Yeah, it means that the maximum amount of oxygen that can be present in the present in the water at that present in the sample of water at that temperature.
That I'm asking that what is the expected level of saturated dissolved oxygen? Generally, normally you can expect in the range of 5 to 7 ppm, isn't it? Okay. Normally you can expect 5 to 7 in that range. Now my
5.8,
question is
five,
the
five, 5 to
5.
6, 5.
Okay. Anyway, now my next question is that why we have mentioned the temperature.
Because at higher temperature the value can be different. Value is different.
In what way does it differ? How does it depend upon temperature?
With increasing temperature, it the value decreases.
Value decreases. That means you say that the solubility of oxygen, naturally that it's a gas in the water. So naturally with increase in temperature, the amount of dissolved oxygen is expected to be decreasing. Okay, isn't it? Now my
Yes,
question
yes.
is, suppose if there is less than the saturation level of dissolved oxygen for a continuous period of time, okay, then what will happen to the aquatic life?
In aquatic life, the fishes respire through their gills, and it is the dissolved oxygen from where they respire. So it will make a it will affect the respiration of the aquatic animals, especially the bigger ones, that is whales and dolphins.
Now my next question is that uh, as far as the dissolved oxygen is concerned, what are the factors other than temperature can influence the DO level in water?
Impurities.
Impurities in the sense, which kind of impurity do you mean actually?
Impurities such as bicarbonate, sulfates.
Bicarbonate sulfate. Okay. Now my next question is that uh, this Winkler method, whether you have followed in your virtual lab, that is the just Winkler method or modified Winkler method?
Modified Winkler method.
Modified Winkler method. In case of the modified Winkler method, why you are saying it's the modified Winkler method?
I don't know.
Okay, it's all right. Or you do one thing, you just check which set you have got. Accordingly, you fill up that. Okay, and within 12:45, you submit it. Is it clear? You can leave. Okay. Next, artist man. Yes.
Yes, sir. Yes, sir.
Okay. Okay.
Good
Fine.
morning, sir.
Very good morning. Very good morning. Have you received any mail right now?
No, sir, I haven't checked. I was in the video
Okay. Okay. Okay.
since.
Definitely. Definitely. Okay. Fine. Now, what are the experiments you have done in the virtual lab?
Sir, we have done actually 4 experiments. The
Okay.
first one was the estimation of no, that was the second one. The first one is something new. The first one is the determination of the acid value of vegetable fatty oil,
Yes.
and the second one was the determination of the chloride ions in presence in water by that what is the argentometric precipitation titration, and the third one was the estimation of dissolved oxygen in
Determination
water
of.
sample by ideometric uh, titration, and the fourth one was the Nernst equation, that partition coefficient.
So, okay. Fine. Now, in case of the partition coefficient of what you have determined.
And the partition coefficients of acetic acid were determined.
Okay. So why you are saying the partition coefficient?
uh, yeah. Partition coefficient said that I don't know properly exactly, sir.
Okay. Now, in case of the first experiment, what's the significance of estimation or determining acid value of an oil?
Acha, acid value of the oil.
Hmm.
Mm,
what do you understand by that? How do you define?
Yes, that acid value. Acha, acid value that define acid value of lubricating oil. That first question that is there. Okay, and that acid value is the amount of milligrams of KOH required to neutralize the amount of free acid present in the 1 gram of oil.
Very good. That means you are saying the acid value, or simply you can say acid number.
Yes,
That
sir.
means how much amount of KOH in milligram is required to neutralize free fatty acid,
Present in
mostly
1 gram of.
in the 1 gram of any oil or fat sample, etc. Okay, fine.
Yes, sir.
Now my question is, uh, what is its significance?
The
Why it is
significance
relevant?
of fatty acid. It measures the rancidity.
Rancidity. Though, what do you understand by rancidity?
Rancidity meaning. Sir, that I don't know correctly. Rancidity means rancidity of the given sample.
Okay, my next question is, in this experiment, do you carry out any blunt titration?
Yes, sir.
In this experiment, do you carry out any blunt titration?
Uh, yes, sir.
What is that
Nothing.
blunt titration? How do you carry out? Means, what do you understand by that?
Sir, that I don't know.
What are the reagent you used?
In this
What's that
experiment,
blunt titration? Right.
blank titration money.
Just open your lab manual. Check
Yes, sir.
that whether did you just check with your lab manual.
Yes, sir. Preparation of standard 900 oxalic acid solution, then standardization of KOH using oxalic acid solution, and then titration of fatty acid using. Sir, no blank titration is I can see.
No blank titration is there. Look at there.
Ja. Sketch. Sir, oh yes, I found it. Blank
Yes.
correction is 50 ml solvent.
That means to determine acid value of any oil sample, you require some suitable solvent.
Yes,
Okay,
sir.
for example. So you are determining this acid value, generally it comes very small amount.
Yes, sir.
Okay. So now for that, to determine for any given oil sample, suppose in this case of fats, you require some suitable solvent in which it dissolves completely. Then you are using some indicator by acid-base indicator titration. For example,
Yes, sir.
phenolphthalein you are using here. Then you
Yes.
are determining the acid value, simply acid-base titration. Now my question is that then what is blank titration then? What is the blank correction?
What is blank correction?
Yes, you just see the what's the solvent you are using. Okay, and in the next titration you are doing with only the solvent. That means
Yes,
you are
sir.
not sure that the solvent what you are using, whether it is 100% means neutral or acid free. Is it clear?
Yes, sir.
Naturally, the if the solvent impacts some acid value, then you will not be able to estimate exactly what's the acid value of the given oil sample. So that's why you require some blank correction separately, only with the solvent. Okay.
Okay, sir.
And what's about the value you are getting in terms of the volume of KOH? Suppose you are subtracting from the volume of with the oil sample, the titration what you are carrying out,
Yes, sir.
isn't it? So that
Yes,
will
sir.
give you the uh, estimation of the what's the
Acid.
possible acid number or acid
Acid
value
value.
of the given sample. Is it
Yes,
clear?
sir. Yes, sir.
Okay, fine. Now you can leave now, and better you just complete that Google form. Okay,
Okay.
and
Thank you,
submit
sir.
it. Stipulated time 12:45.
Okay, sir.
Okay. Okay, next Abunil H.
Yes, sir.
ওকে ওকে ম্যাডাম আপনি ওকে জিজ্ঞাসা করতে পারেন আর
হ্যাঁ, হ্যাঁ।
ল্যাব ম্যানুয়ালও দেখতে চাইবেন একটু হ্যাঁ ঠিক আছে
I
Okay,
will show the lab.
yes, first you show your lab manual.
Okay, wait. Ma'am.
Have you completed?
Yes, ma'am.
হুম।
Okay.
Which experiment will I show?
Experiment number 2. What is your experiment number 2? What is the objective?
Ma'am, by mode method determining of chloride.
Determination of fluoride by Moore method.
Ma'am, here it is.
Yeah. Okay. What is your value?
Ma'am, value for
Value for your experimental value for your sample?
250 gram per milliliter.
250 milligram per liter. Which sample you used? Drinking water or any other sample?
Drinking water.
Drinking water. Okay. Now, this experiment is Morse method. Okay.
Ma'am,
And
what? Ma'am, can
and
you repeat?
what my question is why this experiment is called argentometric method?
Ma'am, because we use silver as the because we use a silver ants to determine whether the particular
You,
amount of chloride is present or not.
you use silver metal as in your experiment?
No, 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 ma'am. We use silver nitrate.
Yes, silver nitrate. Okay, then silver nitrate you used in your experiment,
Yes, ma'am.
and it is primary standard or secondary standard?
This I don't know. I think primary standard because we need to take the precipitate for that yeah, determination of the particular right amount.
Okay, Abunil, if you say it is a primary standard solution, that's fine. Then in that case, in the step 1, what you had done, and in the step 2, what you had done, just open your lab manual.
Yes, sir. Sir, first we need to prepare that 10 by 10.
N by 10.
No, no, no. I think I confused with some other experiment.
Experiment number 2.
Yes, sir. Yes, sir.
What is that? In the step 1,
So preparation of primary standard solution 100 ml N by 50. Yes, sir.
N by 50.
N-
What's that solution? NaCl.
NaC solution.
NaCl solution. And what's the step 2? Look at there.
The standardization of silver nitrate solution by standard solution of
Then-
by using standard solution of NaCl that we
And what
prepared.
do you understand by this? Whether the silver nitrate solution you are using straightforward, is it a primary standard or secondary standard?
So secondary standard.
Because of that, you need to do its standardization. Okay.
Yes.
Because you know it is very much highly photosensitive. Okay. So naturally, you understand it may be analytically to the extent of nearly more than 99% pure or so, but
Okay, sir.
you need to standardize it before the experiment. Is it clear?
Yes, sir.
And you have to freshly prepare. In fact, better the silver nitrate solution.
Yes, sir.
Okay. Madam, you can ask him. Any more
And
questions?
then which indicator you used in your this experiment?
Sir, ma'am, phenolphthalein.
Phenolphthalein. How it is possible? This is not an acid-base titration. You have mentioned this is a biprecipitation titration method.
Yes, sir.
So how it is possible by phenolphthalein indicator? You will understand this.
Sir, I don't.
Okay. It's all right. Now you can leave and you just fill up the Google form. Okay.
So where Google form?
That in your mail you will find that within 12:45.
Oh, I didn't receive it before. I will get it now.
Yes, already you have got it. In just check
okay.
the okay. As per your roll number, you have to fill it up. Okay.
Okay, sir.
That's okay. Fine.
Thank you, sir.
Okay, you can leave.
Yes, sir. Thank you, sir.
Deep.
Thank you, ma'am.
Oh,
Good morning, sir.
good morning. Madam, জিজ্ঞাসা করুন।
আচ্ছা Now, in your experiment number, what is your objective of your experiment number 4?
Ma'am, experiment number 4. Ma'am, determination of partition coefficient of acetic acid between water and butane.
Determination of partition coefficient of acetic acid
Between
in
between water and butane 1
between water and N-butanol.
Hmm.
Then what type of mixture you needed to determine the partition coefficient?
Sorry, ma'am.
What type of mixture?
Ma'am, organic and aqueous.
No, no. What type of mixture means how many type of mixture? In
Ma'am, two
general, how many type of mixture?
two mixture.
What are the?
Water and butane 1.
No, no. How many type of, in general question, how many type of mixtures? It is
Ma'am, two.
homogeneous or heterogeneous?
Ma'am, heterogeneous.
Yes, then mixtures are two types, homogeneous mixture and heterogeneous mixture. Then in
Yes,
partition
ma'am.
coefficient, what type of mixture you needed?
Mm, ma'am, two heterogeneous mixture.
You know, now the answer is heterogeneous mixture.
Yes, ma'am.
Heterogeneous mixture. And we take three component. One is acetic acid, another is water, and another is
And this butane,
N-butanol.
in butanol.
N-butanol. And acetic acid are mixture in these two component, water as well as N-butanol. But N-butanol and water are immiscible. That is
Invisible.
why it is an heterogeneous mixture. Okay. Now, where the concentration of acetic acid more in this solution, in this mixture,
But can you repeat it again?
where the concentration of acetic acid is more in this heterogeneous mixture.
Concentration of acidic is more. I don't know.
But in your lab manual, what
Hmm.
is the value actually shows? Where it is more? Organic media or inorganic? Or water? In butanol or water?
Oh. Ma'am, which value?
Acetic acid. Concentration of acetic acid.
Hmm.
Strength of acetic acid is more in where? In butanol or water?
Ma'am, water? Water.
Achha, listen. Then what is the definition of partition coefficient?
Ma'am, partition coefficient means the ratio of concentration of solute in two solvent layer.
If the composition is changed, then partition coefficient is changed.
If the
If the composition change in your mixture, then partition coefficient change.
yes, ma'am.
Achha, what are the parameter affect the partition coefficient?
What are the parameter? I don't know, ma'am.
Sir, আপনি
अच्छा ठीक है
বলুন
जी।
তাহলে।
हाँ हाँ अच्छा दीप what is Nannet's distribution law?
So, non-discrimination law means this law states that at constant temperature, when different quantities of a solute are allowed to distribute between two imbecile solvents in a contact with each other and exist in same molecular species, then at
That means
equilibrium, yes, ma'am.
suppose in the same molecular species means what do you understand by that? Where the distribution of acetic acid between water and N-butyl alcohol, whether it is going to be going to remain in same molecular species or a different molecular species?
Same.
Same. Okay, fine. And suppose if had it been like that, the benzoic acid in a mixture of benzene and water, then what do you expect in that case?
Sir, please repeat again, sir.
In case of the partition coefficient of the benzene, actually, in a mixture of partition coefficient of benzoic acid in a mixture of benzene and water, then what do you expect the molecular species of benzoic acid, whether it will remain same or different, or in what manner rather?
Different, sir.
Different in what way?
Sir,
Whether there will be association of the molecules or dissociation of the molecules, but dissociation of molecules means benzoic acid.
dissociation.
Dissociation. Okay, now you can leave. You just fill up the Google form and submit it within 12:45. Okay, you can leave now.
Okay. Okay, sir. Thank you, sir.
Best of luck.
স্যার স্টুডেন্টদের কাছে নোটিশ ছিল ইউনিফর্ম পরে বসতে হবে, তো এরা তো মাত্র
হ্যাঁ
দুজন দেখলাম পড়েছে।
হ্যাঁ, ওদের কিন্তু ইউনিফর্ম পরে করতে হবে, দ্যাট ইজ ইম্পর্টেন্ট।
হ্যাঁ হ্যাঁ, নোটিশ ছিল এটা।
হ্যাঁ একদম, ওদের জেনারেল নোটিশ ছিল এটা। আচ্ছা, আদার্স কি জয়েন করেছে?
নেক্সট লটটা স্যার দেখে নিন।
হ্যাঁ, নেক্সট লট। আচ্ছা, সোমনাথ বণিক।
প্রেজেন্ট স্যার।
টার্ন অন ইওর ভিডিও। রাইট, এই সোমনাথ বণিক। ওকে ম্যাডাম, জিজ্ঞাসা করতে পারেন। সোমনাথ।
Yes, sir.
How many experiments you have in the virtual lab you have done?
Sir, 5.
5. What are the 5 experiments? Can you show your lab manual?
Yes, sir.
ম্যাডাম আপনি ওকে জিজ্ঞাসা করুন তো একটুখানি। ও বলছে 5
What is your
experiments.
what is your fifth experiment? What is the objective of your fifth experiment?
Determination of partition coefficient of acetic acid between water and butane.
Okay, fine. And then what's the experiment number 4?
Determination of viscosity of a set of sugar
Whether you have done
solution.
it? Whether you have done it?
No, sir, no.
Then how many experiments?
Sir, 4.
And why you are unable to say that? Okay. Now my next question is that as far as experiment number 2 is concerned, what was the objective of that experiment? You can take help of your lab manual, that's not a problem.
Sir, the objective.
Or where is the lab manual? Just show it to us properly. Okay. Okay, fine. Now what's the experiment number 2?
Sir, estimation of chloride ion present in a water sample by argentometric precipitation titration. Moore method.
Why you are saying argentometric precipitation titration? Can you say something about that?
Yes, sir.
Can you say something about that, about the argentometric titration?
Sir, you mean the steps?
Why you are saying argentometric precipitation by argentometric titration? Where does it come from? And which method we are following actually, this one?
It's a Moore method.
Moore method. Okay. Then you cannot say anything about that. Why you are saying argentometric titration? Acha,
what are the chemicals you used in your experiment?
AgNO3 solution, K2CrO4, NaCl solution.
The AgNO3, in general, what's the name of this solution?
Yes, sir.
AgNO3, what's the name?
Silver nitrate.
Silver nitrate. Now, as per by symbol, the what's the symbol of silver here?
Ag.
Whether it is by
Full name of AG, full abbreviation of AG, abbreviation. AG is the abbreviation.
It's Argent.
Yes.
AG,
I
where does
can't
it come
recall,
from?
ma'am. Actually, it's related with that precipitation or argentometric is.
Yes. Argent. Okay. Now, which chemical, which indicator you used in this experiment?
Yes, ma'am.
Which indicator?
Um, K2CrO4,
K2CR. What is the name?
potassium chromate,
Potassium chromate. And what type of indicator?
inorganic.
Inorganic indicator. What is the color of indicator?
Um,
Okay,
What
my
is
last question. My last question is that Shobnath,
yes,
uh,
sir.
mm, potassium chromate, if react with silver nitrate solution, what will be the product formation?
Potassium chromate.
Suppose potassium chromate react with silver nitrate. Okay, then what will be the product?
It's silver chromate.
Silver chromate. What is its color?
Color, sir. It's brownish red.
Brown red. Okay, fine. You can leave. And have you received the Google form?
Yes, sir.
Have you received the Google form?
Sir, in mail.
In the mail,
No, sir. I
Google
have to
link.
check it. Um,
Just you fill it up, okay, as per your roll number, and within stipulated time, 12:45 p.m. you submit it. This is an
Sir,
integral
when?
part of the lab exam. Okay, now you can leave.
Sir, 12:45.
Within
yes.
12:40, within 12:45 you have to submit. Beyond that, we are not going to
Okay,
accept
sir.
it.
Okay,
Okay,
sir. So may I
fine.
leave now?
Yes, you can leave.
Thank you, sir. Thank you, ma'am.
Okay.
Acha, next roll number 7.
Yes, sir.
Rajdeep.
Yes, sir. Yes, ma'am.
Rajdeep. Okay, fine.
Then,
Madam, আপনি জিজ্ঞাসা করুন।
what is your first experiment?
The first experiment is determination of acid value in
Mhm.
vegetable or fatty oil of vegetable fatty oil.
Acha, what are the apparatus you used?
I use burette, conical flask, then pipette, then volumetric flask,
Mhm.
then measuring cylinder, beaker, then conical flask.
Mhm. When you use volumetric flux?
Uh, Volumetric flask during the standardization for
For
standardization
preparation of? For
standard
preparation
solution,
of
primary standard solution.
time. And then what is the definition of primary standard solution?
It is in case of this experiment, it is primary standard oxalic acid, where the means we use primary standard solution so that the concentration does not change and we
Yes.
get accurate results.
And what is the formula of oxalic acid?
Formula of
Oxalic acid?
it's COOH whole 2 dot 2 H2O,
Yes. Then what is the molecular weight?
63 grams. See, no, 126 grams.
Yes. Then what is the required amount? So if you want to prepare 100 ml N by 10,
0.63 grams.
0.63 gram. Then oxalic acid you use to standardize of
Then
what? What reagent?
KOH.
KOH. Then KOH is what type of reagent? Primary
KOH
or
is
primary or
secondary.
secondary?
Secondary.
Secondary. Then any indicator you used?
Yes, we use phenolphthalein indicator.
Phenolphthalein. Then what type of titration? Oxalic acid and KOH, what type of titration?
Uh, This I don't know.
How many type of titration you have already done?
We have done mode titration, then we
Mode
have
titration
done
is what type of titration?
mode titration like oxidation and reduction.
No, mode titration is oxidation of reduction.
I'm not sure, man.
Then acid base titration is what type of titration?
It is like
With
acid base.
oxalic acid and KOH.
Oh, then it is acid base titration because oxalic acid is acid and
And acid base titration, what are the indicator we use?
phenolphthalein, then methyl orange.
Methyl orange, phenolphthalein. What is the color of phenolphthalein?
Phenolphthalein it's colorless when acidic and when it is basic it's pink, light pink.
Light pink color. Okay. Then what type of uh, acid present in your vegetable oil?
Fatty acids.
What type of acid? Mineral acid or organic acid?
Organic acid.
Organic acid. স্যার আপনি জিজ্ঞাসা করুন এবারে
হ্যাঁ,
আপনি এবার জিজ্ঞাসা করুন
আচ্ছা ঠিক আছে, ওকে ফাইন। আচ্ছা, জাস্ট Rajdeep, you
Yes,
answered
sir.
me one question, that what's the basicity of oxalic acid? Would you be able to say what's the basicity of oxalic acid?
No, sir.
No. Why? You should have. This is very very simple. Okay. Anyway, now you just fill up the Google form. You have already, as per your roll number. Okay. You will check with the set one by clicking the Google form link, and you fill it up and you submit it within 12:45. Okay.
Okay, sir. Okay,
Is it
sir.
clear?
Okay,
Next,
sir.
you can leave now. Next service division you join. Shiroshi,
Yes, sir.
okay. Good morning. Okay.
Good morning, sir.
And best wishes for the lab exam. Now on Viva. Now, Shiroshi, whether you have attended all the lab classes,
Yes, sir.
okay. Whether you have submitted all the time,
Yes, sir.
on time, your assignment, the lab assignment specifically,
Yes, sir, I do.
okay. Now, you just tell me that experience number two, okay. The experience number one, what's the experience number one?
So, determination of fatty acid.
Determination of fatty acid, that's all. Check with your copy. That is,
Determination of acid value of fatty
deter,
acid.
yes, determination of acid value of
Vegetable
fatty
fatty acid.
oil,
Oil. Yes.
isn't it? Okay, fine. Now, how do you define this acid value or acid number?
The number of potassium hydroxide required to neutralize free acid present in 1 milligram of
Uh,
oil.
Actually, I can't hear you properly. Can you speak little bit loudly?
So, number of KOH required to neutralize
Number of
1
QE
milligram.
means what? What number? What's the amount?
Number of milligrams.
Amount, that means what is the amount of QH in milligram is required to neutralize free fatty acid
Yes, sir.
present in 1 gram
1
of
gram.
any given oil sample or fat sample also. Okay, is it clear?
Yes,
So
sir.
whether can you say this is simply on the what's the basis or what's the principle of doing this experiment? Whether we can say this is the acid-base titration?
Yes, sir.
Okay. Now in this case, KOE solution, whether it's a primary standard solution or secondary standard solution,
Secondary standard solution.
secondary standard solution. So what do you understand by secondary standard solution?
So its concentration changes.
Its concentration
And
changes.
changes with time.
Okay. Now my next question is that whether did you carry out any blank titration here?
Yes, sir.
What is that? What do you understand by that?
The titration of fixed known concentration of solvent is analyzed.
Actually, you wanted to know whether there is any acid contained in a given solvent. Okay, because the solvent what you are using, if it is having already some free acid, then it actually increases the acid number or acid value of the given oil sample what you are estimating for. Okay, from that point of view, is it understandable?
হ্যাঁ স্যার,
হ্যাঁ,
স্যার মোহনা দে রোল নাম্বার 15 তো এই স্লটে নয়।
না তাহলে ওকে এ করুন।
হ্যাঁ, মোহনা দে জয়েন করেছে কেন?
না মনোদয় জয়েন করবে না, এক মিনিট দাঁড়াও, দেখছি। আচ্ছা মোহনা, হ্যাঁ he has left the meeting. Okay, fine. Okay. আচ্ছা Shreyosi, my next question is that in case of second experiment, determination of chloride content of a given water sample. Okay.
Yes, sir. Yes, sir.
Now, the which indicator did you use there?
Sir, K2CRO4.
K2CRO4. Or in case of the first experiment for acid value estimation of the given oil sample, what indicator did you use?
Phenolphthalein.
Phenolphthalein. Can you say some? Is there any difference between phenolphthalein indicator and potassium chloride indicator? Phenolphthalein, what's the color change? Does it exhibit at the end point?
Yes, sir. It turns light pink.
In which condition? Whether in acidic condition or in alkaline condition?
Acidic condition.
Acidic condition. How?
So alkaline condition.
Then why did you say something like that? Or in case of with the potassium chloride indicator for second experiment, whether do you say that it is the argentometric titration?
So in case of potassium chloride, it is argentometric titration.
Argentometric solution means what solution?
So
What solution you are using?
silver nitrate.
Silver nitrate solution. Then where does the term come from?
Silver.
From silver. Argentine. Okay, fine. Now, when there will be reaction between silver nitrate and potassium chromate, okay, then what will be the product?
Silver chromate.
So what's in color?
Brownish red.
Okay, fine. Now you can leave the okay Viva, and you just fill up the Google link, Google form as per your roll number, and within 12:45 p.m. you submit it. Okay.
Yes. Thank you, sir.
Okay. All the best.
Thank you, sir.
Next, Sujata Vishwas. Sujata, what's your roll number?
The roll number 9.
Okay, very good. Good morning. Okay.
Good morning, sir.
Just a minute.
Sujata, তোমার experiment number 1 and experiment number 2.
Yes, ma'am.
Okay. And then what is the chemical reaction of experiment number 1? What is the name of this chemical reaction?
Yes, ma'am.
Chemical reaction. What type of chemical reaction? How many type of chemical reaction? In experiment number 1,
Ma'am, 2.
no. What is the name of this chemical reaction? Experiment number 2, displacement, double displacement, or combination, or neutralization, or redox. What type of chemical reaction?
Ma'am, displacement.
Experiment number 1,
Yes, ma'am.
what type of chemical reaction?
Ma'am, displacement.
Acid-base titration.
Ma'am, acid-base titration.
And experiment number 2,
Ma'am, titration with hygrometric
yes,
precipitation.
silver nitrate react with chloride present. Silver nitrate react with chloride present in your
Present
sample.
like that.
Then what type of reaction?
Ma'am, primary standard.
This reaction depends on any pH value. The pH of your sample depends on any parameter, any factor affect this experiment.
No, yes, ma'am.
What are the parameters? What is the parameter? This this reaction is temperature dependent or not?
Ma'am, experiment 2.
Yes.
No, ma'am. It has pH. It's
Yes.
depend on pH and
Depends on pH. Silver nitrate react with sodium chloride depends on pH.
no, ma'am. The titration carried out under the condition of pH.
Yes, the titration can. Then what are the in this your experiment? Which one is the primary factor?
Ma'am, silver nitrate.
Silver nitrate react with sodium chloride. It does not depend upon the pH. Which chemical
Ajay,
actually? The
Sujata, can you say me whether NaCl it's a salt, acid, or base? NaCl,
So it's a salt.
and what about silver nitrate?
So it's a
What is that?
so it's also a salt.
It's also a salt. Okay, very good. Now, what kind of salt? These are whether normal salt, acid salt, basic salt,
So acid salt.
acid salt. How?
So because
Whether in NaCl there is any H plus ion present, in AgNO3 whether there is any H plus ion present.
H plus.
These are simply normal salt. These are simply normal salt. Now suppose NaCl.
Hmm.
So aqueous solution of the NaCl, whether it is neutral, alkaline, or acidic.
Yes, sir. So neutral.
Neutral. So therefore, in case of the NaCl solution, as you were saying, the neutral solution, whether technically can you say that the hydrolysis of NaCl takes place? Does it take place? Yes or no? Because NaCl plus H2O,
Yes, sir. Take
then
place.
you are getting what? NaOH plus
NaOH plus.
HCl.
HCl.
So whether you can say that the hydrolysis of NaCl, does it take place?
Yes, sir.
Take place. And in case of the silver nitrate, what will be the aqueous solution of the silver nitrate? Whether acidic, alkaline, or neutral?
Sir, acidic.
Acidic. Why? So in this case, you can say the hydrolysis take place.
Place.
Now my question is, what is the optimum pH level as per as the Morse titration of argentometric titration for chloride determination? Optimum pH.
So 6.5 to 9.
How much?
6.5 to 9.
6.5 to 9. That is not exact ideal condition. Okay. So now best Google form within stipulated time. Is it clear? Now join
Okay,
Archisman.
sir.
You can live together. Archisman, okay. Good morning and best of luck. Uh, now, as far as the experiment number 5, you have determined partition coefficient of what? I think unmute. Yes, yes, it is. I can't hear you. Why? Okay.
Archishman left.
Oh,
Sir,
join this now.
sir, am I audible now? Sir,
Now it
am I
is audible.
audible?
Now it is
Yes.
audible. Now it is audible. Very good.
Good morning, teachers. Good morning,
Good morning.
teachers.
Morning.
Yes.
Morning.
Now whether we are audible to you.
Yes, sir. Yes, sir.
Okay, very good. Now regarding the experiment number 5, the partition
Yes.
coefficient of what?
So, acetic acid,
Okay, in a,
water, and one butanol.
okay, very good. Now my
Thank
question
you.
is, why you are saying partition coefficient? Partition coefficient means what?
Sir, partition coefficient is the ratio between. Yeah, I think so. Sir, partition coefficient will be the ratio between solubility in organic and solubility in water. Means
The
the
solubility
ratio
of what here actually?
solubility.
You are in case of the partition coefficient of this
Yes, sir.
experiment actually, the whose partition coefficient you are determining? Which
And,
substance? Partition coefficient of which substance you are determining? You just go through the objective, you just read it properly, then you will be
okay,
able
sir.
to understand. You will be able to say. You just look at the objective. You are determining partition coefficient of acetic acid.
Yes, sir.
That is your objective.
Yes, sir. Yes,
And
sir.
why you are saying partition coefficient? Because you are finding actually the distribution of acetic acid in a heterogeneous mixture.
Yes, sir.
In a heterogeneous mixture of what?
Water
Water
and
and
butanol.
benzene alcohol or one
Yes, sir.
butanol,
Yes.
whatever you say. Now my
Yes, sir.
question is that why you are saying heterogeneous mixture? Without heterogeneous mixture, whether is it possible to determine partition coefficient? Yes or no?
No, sir.
Yes, because in a homogeneous mixture, how will you determine? There will be no
Yes.
partition.
No
There is
partition because it will mix or something. That's all.
yes, exactly. So that means here you are observing actually the distribution of amount of acetic acid into
Yes, sir.
different solvent layer,
Yes,
which is
sir.
very much means applicable.
Butanol and water. Yeah,
Yes,
with a
which is very
separating
much applicable in case
funnel.
of different types of solvent by solvent extraction method. You can
Yes,
separate
yes.
the impurities. Okay,
Yes, sir.
so from that point of view, and now I would like to know that suppose you are preparing two solutions, the solution 1 and solution 2. Okay, to determine the partition coefficient of acetic acid in a heterogeneous mixture of N-butyl alcohol and water. Now my
Yes, sir.
question is, do you expect that the partition coefficient value when you are determining at the same time, at the same temperature, or from the
Sir,
by preparing more than 2-3 solution, whether the partition coefficient for each solution is going to be different, same, yes or
sir,
no?
5 ml and 10 ml, the values will be different.
5 ml, 10 ml, that is different thing. I am saying asking the partition coefficient value of acetic acid.
Yes,
That is
sir.
going to differ
Partition coefficient value of acetic acid.
at a given temperature, at a room temperature.
At a given temperature, no, sir, it won't differ.
So that then mean what is the Nernst distribution law?
So at constant temperature, Nernst distribution law says that at constant temperature, when different quantities of a solute are allowed to distribute, then into immiscible solvents, then the ratio, then into immiscible solutes, then at equilibrium, the ratio of the concentration of solute in two solvent layers is constant.
That's why. Okay. Now my provided you just see that they should be this should be in the same molecular species as far as the solute molecules are concerned.
Yes, sir. Yes, sir.
Otherwise, that is the limitation. Okay. Now my next question is that uh, in the suppose in the separating funnel, okay,
Yes, sir.
you are getting one organic layer, another is aqueous layer.
Yes,
Which
sir.
layer means between top and bottom layer? Which layer is organic layer? Which layer is aqueous layer?
So top layer is organic layer and bottom layer is aqueous layer.
Okay, then in which layer do you expect the more amount of acetic acid?
So more amount of acetic acid in bottom layer.
How?
With no, sir. With
Because
water
you
it
just
won't.
you are
With
using
butanol
titration,
it will. Sir,
because you are
butanol
doing
with.
a you just look at here. You are
Yes.
using same NOH solution
Yes.
to
Yes, sir.
determine the acetic acid, and in
Yes,
that
sir.
case, you are actually for aqueous layer you are taking 10 milliliter, and whereas
Yes,
for
sir.
organic layer you are taking 5 milliliter. So that means it is
Yes.
expected that in the organic layer you are
With
getting the,
butanol, yes, sir. With 5 ml butanol only, it will give more acetic acid. That's why with 10 ml we check with water also.
and that's why you if you see the
Yes, sir. Yes,
calculation
sir.
part, there you
Yes,
find the C organic by C aqueous,
yes, sir.
and
Yes,
that
sir.
value is getting greater than 1. So what's the value do you expect the partition coefficient of acetic acid normally?
Sir, partition coefficient. Sir, what can we repeat?
In your experiment actually, what's the expected value of partition coefficient of acetic acid?
So between 1 to 2 something, 1.2 to 1.3 or
Okay,
1.4 something.
okay, it's all right. Now, best of luck. You just fill up
Thank you,
the
sir.
Google form and
Yes,
you
sure, sir.
submit within stipulated time 12:45.
Okay, sir.
Next. Okay, you can leave. Aditya Chakraborty, join.
Yes, sir.
Okay, fine.
Sir, before starting, I have some questions regarding the Google form. Can you just clarify me this?
What's the question? What's your question?
Yes, sir. First question is, in the first question, you asked a question that how will you prepare the standard N by 50 A solution? Sir, will I have to write what is the total procedure?
No. Just one, two sentence that how will you do that? Okay.
Okay, sir.
Hmm.
Okay,
In
and
short, you have to
secondly,
write.
yes, sir.
Okay.
And secondly, what stage indicator is used?
That you try to understand on your own. Secondly, what?
And sir, in the third question, sample water preparation in the step 3, how will you proceed? Total procedure and what is the chemical reaction? Will I have to write all the chemical reactions and how I
No.
will proceed?
Okay, how will you proceed means in brief you just write, and that if there are chemical reaction that also you have to write. Okay. if it is
Okay, so
possible.
there is a lot of chemical reactions. That's why I am
No,
asking.
not all chemical reaction you don't have to write. Only the most important one you understand that you write. Okay,
Okay, sir. And
fine.
the last question. Yes, sir. In the last question, what is the sorry, in the fourth question, if for 100 ml sample water, 4.1 milliliter of B solution is required, sir. In when I will calculate the DO, then will we consider the strength which we got in the second question?
Exactly, right.
Okay, sir. Okay, okay,
Absolutely right. That you have to follow.
okay, sir.
Hmm.
Okay, sir. My question is finished.
Okay. So how many experiment you have done in the virtual lab?
Sir, we have done only 5 experiments, and the fourth experiment data table is incomplete.
Okay, madam, you can ask him.
Okay.
Good morning, ma'am.
Now, good morning. Uh, Now, what are the chemicals used in your fifth experiment, partition coefficient?
Acetic acid and butan 1-ol.
Acetic acid and butan 1-ol. These are the
Yeah.
chemicals used. And what are the
Yeah.
reagent?
Oxalic acid, NaOH solution, distilled water, and acetic phenolphthalein indicator
Phenolphthalein indicator. Why you use phenolphthalein indicator?
to get the color change.
But why? Why you use phenolphthalein? Any other indicator can you use?
Uh, Phenolphthalein indicator. Sorry, ma'am. No, ma'am. Any other indicator cannot be used.
Why? Explain. Why oxalic acid you used in this experiment?
Oxalic acid. Uh, okay. For standardization of NaOH solution,
Standardization of NaOH solution. Then what type of standard solution of NaOH?
uh, secondary solution,
Secondary solution. Then oxalic acid NaOH. What type of titration?
volumetric titration. Hello, ma'am.
All these are volumetric titration. Then why, what type of titration? Oxalic acid and base. What type of titration? What is the color of phenolphthalein in your acid solution?
Phenolphthalein in my light pink. Hello, ma'am.
What is the color of phenolphthalein in base?
Phenolphthalein in base. Pink.
Acid pink, base pink. Then how the change is
Sorry.
determined?
Um, greenish or
Okay. Then where the concentration is more in partition coefficient if you use water and in butanol solvent? In which layer the concentration of acetic acid is more?
in butan 1-ol.
In butanol. Why?
Yeah. So organic layer also organic layer.
Organic layer.
Yes.
Organic layer. Okay. Then, in your experiment, what are the composition you used? Acetic acid, water, and then butanol. What is the composition?
Composition means
Composition in the mixture.
huh? Ma'am?
Mixture in the mixture. What is the composition? Water, in butanol, and acetic acid.
Yes, ma'am. And which were invisible liquids.
Okay, it's all right. Orito, okay, fine. Best of luck.
Thank you, sir.
Okay, you fill up the Google form within stipulated time and submit by 12:45 maximum. You
Okay.
can leave now.
Okay, sir. Thank you,
Okay.
sir.
Next, roll number 12, Anjil.
Yes, sir.
Okay, fine. Anjil, good morning and best of luck. Now my question is
Good
that
morning, sir.
uh, how many lab you have attended in
So
terms of
all the
experience?
labs. So we have done 4 experiments and all the labs are attended.
What are those experiments?
So the first experiment is to find the acid value of a given oil sample. The second is the estimation argentometric titration, means that to find the chloride ions present in a given water sample. Third is uh, the to find the dissolved amount of oxygen in the given water sample, and the fourth is to find the partition coefficient
Partition coefficient of what?
of acetic acid when the butanol and water are used, are the two immiscible salts.
Okay, fine. Out of these four experiments, which experiment you feel comfortable?
Sir, in the second experiment to find the argentometric to find the
Which
chloride ions present, I feel comfortable, sir.
Okay, fine. Now my question is that uh, regarding Moore's method of chloride determination by argentometric titration, the what is the optimum pH?
Sir, the pH optimum pH should be between 7 to 8.
7 to 8. Why
Yes,
it is important between 7 to 8? If it,
sir, because sir, if you go if you conduct the experiment at higher pH, then the AgNO3 which is used will precipitate, which get precipitated as AgOH, and at lower pH less than 7, the chromate ions will get converted into dichromate ions and will interfere with the end point of the titration.
okay, my next question is that between which one is more soluble, the silver chromate or silver chloride in terms of the solubility?
So silver chromate or silver chloride?
Hmm.
So silver uh, chloride,
I mean,
silver chromate is more soluble in water.
okay. Now, though you are finding the solubility product is actually for silver chromate is going to be less than that of the silver chloride. So during titration, suppose a chloride content sample, okay, water sample, where you have
Yes, sir.
taken the indicator potassium chromate, for example, okay.
Yes, sir.
Now you are adding silver nitrate solution from the burette. What is the observation?
Sir, uh, sir, it will uh, form a AgCl precipitation.
There will be two reactions simultaneously. One is
Yes, sir.
AgCl and another is
and another is from uh, chromate to K, uh,
Ag2 CrO4, silver chromate.
yes sir, yes sir,
Okay. So
yes.
then when do you find the end point finally?
So sir, endpoint is found by the when there is a brown PPT of Ag2 CrO4.
So that means when you
When
find the all the chloride contents
the
are being
will
actually completely reacted
use
or
the all the
used.
chloride will be reacted and the excess of chromate will actually react with the silver and will form a brown precipitate.
Okay. Now my question is that uh, did you carry out any blank titration in this experiment?
Blank titration is blank titration in this experiment, yes sir.
Okay. So in that blank titration, whether do you expect any precipitation?
uh, in the blank titration,
Yes.
uh, yes sir, lemon yellow, uh, some no 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 sir, no no sir.
Because you are doing the titration taking either deionized water or distilled water.
Oh ha,
Okay.
yes sir,
By adding
yes sir,
potassium chromate indicator to understand the sensitivity of the indicator potassium chromate, that
yes
at
sir,
what point does it change from lemon yellow to the reddish brown color, isn't it?
yes sir,
So
yes sir,
naturally, there is no other chloride or anything so that which may because of that there will be any question, no question of any precipitation formation. Is it clear? Understandable?
yes, yes sir.
Okay. Now the last question. Suppose what do you understand by normality?
Sir, it normality is the amount of gram equivalent mass dissolved in 1 liter of the solution, 1 liter solution.
Gram equivalent mass of what?
Gram equivalent of the solute dissolved in 1 liter of the solution.
Okay, very good. Now you just see, you can leave the Viva and you complete the Google form and just submit within 12:45 p.m. Okay?
Okay,
Is it?
okay, sir.
Okay, fine.
Okay, thank you, sir.
Uh, Next, you join.
Good morning, sir.
Good morning.
Good morning,
Good morning, ma'am.
Sanjay.
Yes, ma'am.
Then what is your objective of your second experiment?
Second experiment objective is estimation of chloride ions present in water sample by
Why
Moore
why
method.
why this experiment is needed to determine the chloride ion? If chloride ion is high in your sample, then what is the physical property changes? What type of sample you use? Drinking water or any other water?
Drink, drinking water.
Drinking water. If your drinking water, the chloride ion is very high,
Hmm.
then what is the change of your physical property of drinking water?
Ma'am, chloride generally increases electrical conductivity and if it is no
Electrical conductivity. Physical property is electrical
physical
conductivity.
properties. Sorry, ma'am.
What is the permissible limit of chloride ion present in your drinking water? What are the chemicals you used?
Ma'am, chemicals we use the uh, NaCl NaCl solution, AG, AgNO3 solutions and distilled water.
And distilled water. Or any other chemicals you don't use?
Ma'am, deionized water and K2C or O4.
K2C. Deionized water is not the chemical. Okay. Now, what type of reaction
What type of reaction?
in this experiment?
AgNO3 reacts with fluoride in 1:1 ratio,
Hmm.
and the pH level must be in 7 to 8 range.
Hmm. What type of reaction? What is the name of this reaction? What is the name of this titration?
Adgenometric precipitation
Arjuna. And
titration.
what is the reaction?
Shubhodippa, you join at your time, not now.
What is the permissible limit
Okay, ma'am.
for drinking water? Fluoride content.
Yes, ma'am.
Permissible limit of fluoride content in your drinking water.
Okay, Singesh, it's all
Yes.
right. Uh, do you know what's the permissible limit of
No,
drinking
sir.
water fluoride level content?
No, sir.
Why? In there was a question actually in your lab manual. We are asking from there only. And during the virtual lab, many times it was discussed. So many times. Anyway, all the best
Singesh
with
also,
the
sir,
Viva
Singesh
and with
also
the
without
result in
uniform.
uniform as per your roll number and submit within 6 to this time. Okay?
Okay, sir.
Okay, fine.
Singesh also without uniform.
Ma'am, where do you find our uniform now? The college is not yet started.
It is noticed from your college.
Yes, ma'am, I know,
It is a
but
notice
how to?
circulated from your college.
Sorry.
Roll number 14, IS Dotto. Join. IS Dotto.
Has not joined
There is
yet.
no IS Dotto. Okay. Mona,
Mona.
you join now.
Good morning, sir.
Good morning.
What is your objective of your third experiment?
Third, estimation of dissolved oxygen in sample water by modified Winkler method.
What type of reaction occurred in this experiment?
Uh, what kind of reaction? Mm, like redox.
Redox. What is the name of this citation?
Uh, Ma'am, name of the titration. The name of the process the name of the method we use in this
How many?
titration.
Titration. Name of the titration. How many type of titration?
Modified Winkler method.
Modified Winkler
Oh,
method.
iodometric titration.
Iodometric.
Iodometric. Oh,
What is the
oh.
specialty of iodometric titration?
Here we use starch as an indicator,
Yes.
which will help us to indicate the starch iodine, iodine ion, I minus ion in the present in the sample.
I minus ion. Starch react with I minus. What
Starch
is the
help us
color?
to
What is the color?
dark blue.
dark blue. Dark blue color of starch in which medium? Iodide or iodine?
Then it becomes colorless actually. At the end point, it become colorless, transparent.
The endpoint become colorless, but my question is the starch color blue gives in which medium? I minus or I2?
Uh, I2, I2,
And
iodine.
iodine. Are any other specialty in this experiment?
Any other specialty? Azide modification. We use azide modification
Iodine,
because
iodinated titration, the formation of iodine is in dark medium or in light medium?
ma'am, can you repeat the question?
The formation of iodine is in dark media or in light media? During
Formation
this
of iodine. Uh,
experiment,
dark, dark.
this is the most important specialty for iodinated titration. Iodine does not form, then the titration does not occur. Okay. Now,
Okay,
what
ma'am.
are the chemicals used?
What are the
Chemicals.
what are the chemical we use? Um,
For
K2Cr2 is potassium dichromate solution.
what
Um,
some dichromate solution do you use?
N by 50, normality N by 50.
Yes. Why you use?
Because it's a primary standard solution to standardize the secondary standard solution or the sodium thiosulfate solution. We need a primary standard solution to
Okay.
know the secondary standard solution strength.
Acha,
Okay.
one thing actually. Hello, Mona. Mona, am I
Yes, sir.
audible?
Yes, sir.
Okay. My question
Yes,
is
sir.
that you are using potassium dichromate solution to standardize which solution?
Sodium thiosulfate solution.
Sodium thiosulfate solution. What's the molecular formula?
Molecular formula. N2 uh, N2S2 um, O3. N2S2O3.
N
Na2S2O, Na2.
O N বলছে স্যার N
Na,
Sorry, Na2. Sorry. Sir, Na2,
Na2S2,
Na2. Na2S2O3.
Na2S2O3. Not only that, dot 5H2O, 5 molecules of water of crystallization along with sodium thiosulfate, and that is also known as
Sorry, sir.
hypo. Okay, and what
Yes,
kind of
sir.
reaction
Yes.
between sodium thiosulfate and acidified potassium dichromate is taking place? What type of reaction it is? Is it a redox reaction?
What kind?
I
Yes,
am
sir.
asking. I am just giving you hints. Is it a redox titration?
So it's an iodometric titration.
Okay, it's all right. Now, okay, fine. Best of luck. You can leave
Thank you, sir.
Viva, and you just fill up the Google form, okay? And within stipulated time, as per
Thank
your
you, sir.
roll number, you submit it. Okay. Best of luck.
Thank you, sir.
Okay.
Thank you, sir.
আচ্ছা কি বলে আয়েশ দত্ত is absent. আয়েশ দত্ত is not here.
জয়েন করেনি তো।
জয়েন করেনি একদম, জয়েনই করেনি। ও
আমরা স্যার একদম শেষে ওকে দেবো পুরো
হ্যাঁ এখন আর নয়, হ্যাঁ নেক্সট। আচ্ছা ওকে নেক্সট জয়েন, that is Subhodippa Dey.
Good morning, sir. Good morning, ma'am.
Good morning. Open your just turn on your video.
Good morning, sir.
Show your lab manual.
নামটা
Okay, at least any experiment you show it.
experiment number 2.
Okay. Did you submit all the time your lab assignment on time? Okay,
Yes,
fine.
sir.
Now, in continuation of our actually previous Viva, I would like to ask you that during determination of dissolved oxygen, what's the method we follow?
We follow the iodometric method, iodometric titration. স্যার মানে পুরো প্রিপারেশনটা মানে পুরো প্রসেসটাই কি বলবো?
What's the actually means that is modified Winkler method.
What is because we use the iodine here and sodium thiosulfate solution. This is why this is.
No. Actually, the in other case also you will use that is different thing. What I'm asking you that why we are saying we are following this modified Winkler method. Why you are not saying only Winkler method? What's the difference?
Okay, in the modified Winkler method, we use sodium azide, but that is not in the first Winkler method. Modified Winkler method, আমরা sodium azide use করি যেটা আমরা.
Why we are using that? You just open your lab manual. You just check with the theory part. You just see in the theory at the under the theory at the means at the bottom you will find there the agile modification. What is that? Why we are
doing as sometimes in water the in water when we
nitrate sulfur
when we prepare the when we find the dissolved oxygen in water, there is also present NO2 minus and SO3 2 minus in the water, and that causes some problem to calculate the actual amount of dissolved oxygen in the water. That is why we use azide modification to extract the NO2 minus and SO3 2 minus from the solution.
Okay, those are going to also react. So naturally, it is interfering. It's actually the exact estimation of the dissolved oxygen. Okay.
Yes.
Now my next question is that whether we are able to determine directly why you are saying repeatedly suppose or why we are following the iodometric titration.
Because
whether we are able to estimate dissolved oxygen by this titration directly without iodometric titration.
No.
Then how you are doing? Now whether the oxygen is reacting directly with iodine or in between some other reagent we are using. What's the reagent we are using most normally?
We are using manganese sulfate.
Yes, why we are using manganese sulfate solution?
The manganese sulfate is reacting with the dissolved oxygen and it is forming manganic hydroxide, and manganic hydroxide precipitate is brown PPT forms a brown PPT, and then we use concentrated H2SO4 to dissolve the brown PPT and it is forming a brown color.
Yes, actually. Okay, I'm just interrupting. So that means the manganese sulfate solution, that means manganese oxide, this is the oxygen carrier. Okay. Yes. And that actually is the undergoing reaction. You just you are forgetting to mention in between you are using actually that alkaline azide potassium iodide solution, the potassium iodide. So that is going to react finally. Okay.
Yes, sir. Potassium iodide.
And then in the acidified medium, you are finding this is the actually the storing of iodine in the form of I3 minus complex. That means with excess I minus from Ki solution, the iodine actually is going to react. Actually, that iodine actually is going to be in the with respect to equivalent amount of dissolved oxygen.
Yes, sir.
That means finally we are doing the titration of amount of iodine we are getting is
Yes,
the
sir.
standard sodium thiosulfate solution,
Yes,
and
sir.
that equivalent amount of the iodine actually is related to the equivalent amount of dissolved oxygen present. So we are unable to determine that by this titration directly without giving any iodometric titration to determine the amount of dissolved oxygen. So that's why we are using in between the manganese sulfate, the manganese oxide, which is going to act as a oxygen carrier.
Okay,
Okay, is it
okay,
clear?
sir. Yes, sir.
Okay, very good. Now my question is that which indicator do you use here?
We use 2 milliliter 1% starch indicator, starch solution.
Okay, now my question is that whether the starch indicator you are using at the very beginning, like other experiment, or
No,
near
no,
the
no,
end
no.
point.
At the end point, we are first we are titrating, and then we
We will
get
not
the
say at
light
the end point, near the end point.
near the end point. We are getting a light yellow color, and then we add the starch indicator. We get a dark blue black color, and after titrating again, it will be colorless.
Okay, very good. My question is that why near the end point? Why not at the very beginning? Whether would you be able to say that?
Because a starch indicator. Hmm,
Because you know already with the iodine it form complex. So when with the more amount of the iodine, so there will be so much complex substances. So naturally you will not get the sharp end point. Okay. So near the end point means the amount of iodine is very less, and by start the visual indicator actually you are able to understand the what's the exact end point. Okay. Is
okay,
it
sir.
clear? Okay. That's all. You can leave the Viva and you complete your Google form and you submit
Thank
the
you.
specific time to your 45. Okay, is it clear?
Thank
Okay,
you,
that's
sir. Thank
okay.
you, sir. Thank you, ma'am.
Roll number 17, Debnath Devariya.
Yes, sir. Good morning, sir.
Good morning. Turn on your video.
Yes, am I visible?
Okay, yes, you are visible. Okay, and audible also. My question is that uh, as per as experiment number one is what's the experiment you carried out? I mean, what's the virtual lab you have done?
So, experiment number one.
Yes.
So, it is determination of acid value of vegetable fatty oil.
Okay. Suppose in your lab discussion actually what's the possible acid value did you get?
So, possible acid value.
Hmm. You just check with your lab manual. What is
So, it's 1.84.
1.84. Okay. What's that?
Milligram potassium hydroxide per gram oil.
Per gram
Oil.
Okay. So that means generally we can say also acid number because that means it is understandable by definition. How do you define acid value then?
So, acid value. It is the milligram of KOH required to neutralize the amount of acid present in the oil.
Okay, very good. Present in oil means in by definition in 1 gram of oil.
1 gram of oil, yes.
For 1 gram of the oil. Okay.
Yes,
So in case of the lubricating oil, what's
yes,
the
sir.
possible acid value do you expect?
10,
No, no, no. In case of the lubricating oil, the generally it is expected less than 0.1. Okay. Have you
Okay, sir.
understood? Okay.
Yes, sir.
Okay. Now suppose we are saying that fats, oil. What's the possible composition of the fats and oils in general? What is
General
this?
composition.
Uh,
Fats. So, fatty acids. Sir, don't know, sir.
why don't in the at the first page what is written there under theory? Look at the reaction. What is that?
It's potassium hydroxide plus any COH. That's
So if
Yes, sir.
somebody asks you,
It is the titration of the fatty acid present with the standard solution of potassium hydroxide.
okay, but what is that? The reaction is written there.
It is RCOH plus K potassium hydroxide that gives
This is a free acid. Suppose free fatty acid present, but generally if somebody asks you how do you define oil and fats, so what do you understand that? What will be the in general composition? I'm saying exact composition. I'm not saying in general. What? Why you are unable to say?
It
These are
is one.
generally yes.
It's 1 gram of oil per fat.
Okay. All right. Which indicator did you use?
Chromate, potassium chromate.
Potassium chromate indicator in this case did you use? How it's possible?
Not this one, sir. It's a phenolphthalein, sir. Sorry. It's phenolphthalein.
Phenolphthalein indicator. Okay,
Yes,
phenolphthalein indicator. How do you understand by its color change at what stage?
So it turns into pink at the end point.
Endpoint pink means in which condition? In acidic condition or in alkaline condition?
If it is not neutralized, then only it turns.
What I'm asking you, in the neutral phenolphthalein indicator solution, whether it is a colored solution.
No,
Then I'm asking that as you are saying by pink color change, you will understand the in neutral point is over or the end point you are getting, for example. Then in which condition, whether it is in acidic condition or in alkaline condition?
In acidic condition.
Okay, so like whatever it is, you just check it. Okay, you just think twice, and you can leave for the Viva, and you just complete the Google form and submit within 12:45. Okay, is it clear?
Okay, thank you, sir.
Okay, thank you.
Next, Ahona.
Yes, ma'am.
Ahona, click on your video.
Okay, ma'am. I am visible.
Yes, you are visible. You are visible, but you are looking a bit nervous. Why you are nervous? Okay,
It's
don't be
the
nervous.
first time I'm giving Viva in college. That's why.
Okay. Madam, you can ask her. Ona.
Okay. Acha, what is your second experiment?
Second experiment. Estimation of chloride ion present in water sample by Moore method.
By Moore method.
By Moore method.
Then what is the name of this citation?
Argentometry precipitation titration.
Argentometric precipitation titration. Why it is called argentometry?
It is determined by titrating the water sample by AgNO3 solution and by using K2CrO4 indicator.
Right, K2CrO4 indicator is what type of indicator?
It is K2CrO4 indicator is
What is the color of this indicator?
at the end of the reaction or at the beginning of the reaction?
No, at the beginning of the reaction, what is the color of this type?
Lemon yellow.
Lemon yellow. And after neutralization point, what is the color?
It is brownish red with white tar bit. In white tar bit, it is brownish red.
Who gives the not the brownish red? Actually, the color is brick red. Then who gives the brick red color?
In the middle state, it is brownish red.
Since silver chloride is white in color, therefore we see that actually it is not brownish red. The actual color is brick red color. Then which who gives the brick red color?
CrO2 minus मैंने Ag with CrO4 O2 minus reacts and gives Ag to CrO4 and it is brick.
Silver chromate. Silver chromate gives the brick red color. Okay. Silver chromate gives the brick red color. Then which medium this reaction occurred?
Which medium it is uh, you mean the pH state?
Yes, yes. Which
It
medium?
is 6.5 to 9.
That means
pH.
neutral. Neutral.
Huh?
That means neutral.
Neutral.
Yes, the medium is neutral.
Medium
Okay,
is
not acidic, not basic. If it is in acidic in nature, then what are the problem arises?
If it is acidic in nature, then um, um, in acid-base medium, the hy- hydroxide ion
No,
reacts with
no.
silver ion and produce.
My question is, if medium is less than 7, that means say less than 4, pH is 4, 5, then what is the problem arises?
Oh, the chromate ion is formed. The hydroxide chromate ion forms or
Chromate is formed. Chromate is already present because you use potassium chromate as an indicator. Therefore, in your medium, the chromate is already present. Then, if the medium is in acidic, then what is the formation of chromate ion?
it becomes dichromate.
Chromate becomes dichromate. And what is the color of dichromate ion?
Color yellow.
Chromate is yellow. And what is the color of dichromate?
Reddish brown.
Okay. Now, in this experiment, do you blank correction?
Can you repeat them?
In these experiments, you have done in any blank correction?
Yes.
Why?
Because um, I know the answer. It's just
Okay, it's all right. Okay, no, don't be nervous. Okay, it's all right. You just you can leave the Viva and then you fill up the Google form and submit within stipulated time 12:45. Okay.
okay, sir.
Okay, fine. Okay, fine. Okay.
Next is 20, roll number 20, no?
No, 19.
19. Konishko.
19. Achha, 19.
Good afternoon, ma'am. Good afternoon, sir.
Good afternoon.
Konishko.
Yes, sir.
Acha, am I audible?
Yes, sir. You're audible.
Okay, fine, fine. Uh, as far as potassium dichromate is concerned, okay.
Yes, sir.
What's its molecular formula?
So K2Cr2O7.
Okay, potassium dichromate. Now, if you consider the acidified potassium dichromate, then how will you determine the equivalent mass of potassium dichromate?
So equivalent mass of potassium dichromate is equal to molecular mass of the molecule, molar mass of the molecule divided by its valency.
So that I'm asking. In case of the how you determine potassium dichromate, the equivalent mass, the molar mass divided by what?
The valency of the molecule.
So what is the valency?
What is the number?
So 2. Most probably.
2. How? Suppose in acidified medium from K2Cr2O7. So what will be the change in oxidation state of chromium? What will be the change in oxidation state of chromium?
Sir, no idea.
No idea. Okay, first of all, you tell me the acidified potassium dichromate, it is an oxidizing agent or a reducing agent?
Sir, it's an oxidizing agent.
It's an oxidizing agent. Okay. And then when there is a reaction between acidified potassium dichromate and sodium thiosulfate, the sodium thiosulfate, whether it is an oxidizing agent or a reducing agent?
It's a reducing agent.
Reducing agent. So what will be the changes from potassium dichromate to which and from sodium thiosulfate to which?
Sir, chromium's oxidation
Suppose
change.
I am saying dichromate ion to what and suppose thiosulfate to what?
So, sodium dichromate plus sodium thiosulfate equals to.
Okay, then in case of the sodium thiosulfate, how will you determine its equivalent mass?
So same equals to molar mass by valency.
So what is valency? Suppose you are saying valency. What is valency in this case?
So 2.
2. So always the 2 is your priority. I think you should verify, check. Once you leave the Viva, you should check the how we can determine the equivalent mass of potassium dichromate, how we can determine the equivalent mass of sodium thiosulfate. Okay. Now we
Okay,
can
sir.
leave the Viva and you fill up the Google form and you submit within stipulated time 12:45. Is it clear?
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Next, Rana Ghoroi.
Present, sir. Good morning, sir. Good morning, ma'am.
Good morning.
So turn on your video. Madam, you can ask it.
You join at 12.
Okay.
Okay, ma'am.
Now your experiment number 5. What is your experiment number 5?
Determination of the partition coefficient of the acetic acid between water and the butanol.
What is the formula of acetic acid?
CH3CHH.
This is monobasic or dibasic acid?
Ma'am, diabasic.
Dibasic acid. Okay.
Yes, ma'am.
Okay. Now, water and N-butanol you used when water and N-butanol are mixed. It is what type of mixture it forms?
Yes, ma'am. Ma'am, can you repeat, please?
Water and N-butanol. If you mix water and N-butanol, then what type of mixture it forms? How many type of mixture in
Actually,
general?
madam, asking you whether it's a heterogeneous mixture or homogeneous mixture.
Heterogenic.
Yes,
Heterogeneous.
because you are determining partition coefficient. Unless there is partition, then how will you determine the partition coefficient? That's the question from madam. Okay,
Okay, sir.
madam, continue.
But alcohol is mixed with water. Is it homogeneous? Ethyl alcohol? Is it mixture is homogeneous or heterogeneous?
Ma'am, heterogeneous.
Why?
Ethyl alcohol.
Because you just see, you have already studied at your +2 level. There's so many organic reaction. We carry out the reaction in alcoholic solution. Alcoholic solution means that is mostly ethanolic solution. That means ethanol along with the water. For example, in case of any chemical reaction of alkyl halide, okay, with ethanolic KOH, you find the nucleophilic elimination reaction. Then how do you say that ethanol in water is insoluble? That is soluble. It forms a compatible mixture, miscible mixture, homogeneous solution. Can you say that the ethanol can form the homogeneous mixture with water because of the presence of OH group, and whereas in the same homologous series you are finding that the higher member like N-butyl alcohol, that it becomes incompatible with water. Can you say regarding that anything?
Okay. But during experiment, why your sample taken in the organic medium is 5 ml and the aqueous medium is 10 ml for determination of acetic acid, concentration of acetic acid?
Ma'am, I don't know.
Where the concentration of acetic acid is more, in aqueous medium or in organic medium?
Ma'am, please repeat.
Where the acetic acid, concentration of acetic acid is more, in aqueous medium or in organic medium?
Aqueous medium.
Okay, fine. If you say in the aqueous medium, then what's the how did you calculate the partition coefficient of acetic acid? What's the formula? You just check and let us know. In your copy, lab manual, you just check whether you had submitted earlier assignment.
Yes, sir.
Then you just check, you verify what's there. That is experiment number 5. You just see the
Yes.
calculation part, partition coefficient. What is that formula?
It's,
It is not there. C organic by C aqueous.
yes, sir. Yes, sir. Yes, sir.
And what's the
Yes,
value you have got?
sir. Organic 1.4172 and aqueous is 1.1318.
Okay, that is different thing. What I'm asking you, the what's the partition coefficient value you have got finally?
1.25.
Then you just look at here. You are writing the formula C organic by C aqueous.
Yes, sir.
Okay, then you are getting the value more than 1. So it is obvious that the solubility of acetic acid is more in the organic solvent than that of in aqueous medium. That
Yes.
was the question. Is it
Yes.
clear? Understandable
Yes.
now?
Yes, sir.
Okay. Okay. Best of luck. And you can leave the Viva and you just fill up the Google form. Okay. And within stipulated 12:45, you submit it. Is it clear?
Yes, sir. Yes, sir.
Okay, fine.
Thank you, sir. Thank you, ma'am.
Okay, fine.
Okay. Now next is 21. Roll number
21, Adrija.
নেক্সট ব্যাচ একজনও আছে 12টা বাজে তো।
Next, Adrija, join.
স্যার 21 to 25 কেউই নেই।
ওরা তো ছিল তো, ওদের গেল কোথায়?
বললাম 12টার সময় জয়েন করবো, 12টা তো বাজে।
হ্যাঁ, ওখানে জয়েন করেনি কেন? ঠিক আছে, করবো তো বাসে। ঠিক আছে। না করতে পারবো না, অনেক একসঙ্গে প্রচুর রয়েছে।
একটার মধ্যে শেষ করতে পারবো না।
হ্যাঁ।
তাহলে 22, 21 to 25 এর পরে কে আছে? 26 to 30 এর মধ্যে কেউ আছে?
না ওরা ওরকম পরপর জয়েন করবে, জয়েন করে এইভাবেই আছে। হ্যাঁ, জয়েন করেছে। Adrija, now it is your turn. Turn on your
Yes, sir.
video.
Good morning, sir.
Good morning. Madam is asking you a question, okay?
Yes, sir.
Okay. Good afternoon, Adrija.
Good afternoon, ma'am.
Now, what is your second experiment?
Ma'am, second experiment refers to the estimation of chloride ion in water sample using the Moore method or the argentometric method.
Can you tell me why it is necessary to determine the chloride ion in our surface water or in our daily water life?
Ma'am, I couldn't. understand
So
question.
if chloride ion is high, then what are the problem arises? Why it is needed to check the chloride present in the sample water?
Ma'am, if the chloride ions are high in water, then water becomes it. We cannot drink the water for in our day-to-day lives.
Why?
Because it
What are the
co-
physical properties changes?
Adrija, okay, I am just specifying this. Suppose does chloride contain in water
yes, sir.
enhance the hardness level? Yes or no?
It increases the hardness.
Which type of hardness you are saying? Temporary or permanent?
Temporary hardness.
Temporary hardness. How do you define temporary hardness? How do you define permanent hardness of water?
Um,
Now, Adrija, my question is, apart from hardness, does chloride contain or whether the chloride content is having any influence in terms of the corrosion?
Yes, sir. It contributes to the corrosion of the metal pipes through which the water is passing.
Why? Can you say that?
Because it increases the electrical conductivity of water, and in metal pipes the chloride reacts with metal
That means you are
ions.
saying here the corrosion process, the wet corrosion process here in this case is the redox titration. So electrolytic means
yes, sir. Yes, sir.
reaction will take place. So
Yes,
there
sir.
will be the solution becomes more electrolytic in the water condition. Therefore, it is more convenient or means good ambience for corrosion. And from that point of view, there will be more metal loss, and from the anode, in terms of the anode, more oxidation, isn't it?
Yes, sir.
Okay. Now, why you are unable to say regarding the temporary hardness and permanent hardness? That is very simple, actually.
Devdatta 6. One after.
Okay. Anyway, what should be the permissible limit of the chloride content of the water, drinking water in particular?
So the permissible limit of chloride ions in drinking water should be 250 mg per liter.
Okay. Okay. So you can leave the Viva and you fill up the Google form and submit within stipulated time 12:45. Okay.
Okay, sir. Thank you.
Okay.
Ognivo not joined.
Ognivo
Ghosh not joined. Amritesh.
Present, ma'am.
Amritesh, you joined. Right.
Present, sir. Present, sir.
Okay. You turn on? Yes. Okay. Very good. Fine. Hello, Amritesh.
Yes, sir. Yes, sir. Present.
Okay, fine. Now, can you say how many experiments you have performed in the virtual lab?
Sir, 4
Amritesh, turn on your camera. Turn on your camera.
turned on. Ma'am, I turned on.
But you are not clearly.
Yes. Little bit difficulty in visibility.
Ma'am, is it okay?
Yes.
Have you put on your uniform, college uniform?
Yes, ma'am.
Amritesh, what's the first experiment? What's the objective of that first experiment? Can you say?
Sir, determination of acid value in vegetable fatty oil.
Determination of acid value of
vegetable fatty oil.
okay. Now, what do you understand by the fatty oil or the fats? What do you understand by that? And what is the difference between oil and fats? Okay, that I will later on. But first of all, you just say what do you understand by fats and oils?
So the acid value of oils or fats indicates the amount of fatty acid
That is
present in
different
it.
thing because unless you know the what is fats and oils, then the next step, the what's the objective of determining this first experiment, you will not be able to understand. So that's what I'm asking. Means what's the general concept about the oil and fats means what in terms of the composition? General composition, I'm saying. Your performance was good actually in the theory. I found that in your in terms of the assignment, first internal, etc. But why you are unable to say something like that? You just see because the earlier one also the other one I asked him the same question, also unable to answer. You just see now you ask me just you answer me the what you understand by acid value or acid number.
So the acid value of oils or fat indicates the amount of fatty free acid present in that solution
Yes,
sample.
you are finding that that means you are determining the amount of free fatty acids in present.
Yes,
That
sir.
means why it is happening? That means oils and fats you are saying simply these are actually triglyceride ester of long chain fatty acid.
Long chain carbon atoms.
Okay. So naturally because of hydrolysis, because of oxidation reaction, because of so many reasons that undergo degradation and it produce free acid, free fatty acid. Okay,
Yes,
so
sir.
that means aging of the fats, oil, rancidity, etc. Quality, we can understand simply
Rancidity
by
of sample
determining
in
the
the
acid
poor
value.
quality. Yes, sir.
Okay, my
Rancidity of
question is
sample in
now,
terms of poor quality of fats and oils.
now triglyceride ester. So what is this alcohol? What is this alcohol here actually? Ester, you are finding the triglyceride ester of long chain fatty acid. So triglyceride means from which alcohol do you get? You know that simply from the polyol, that suppose ethylene glycol, CH2H, CH2OH, and it is actually glycerin,
Yes, glycerin.
CH2OH, CH2OH, CH2OH. And with
CH2OH.
all these three OH group, there will be extra formation of other three long chain fatty acid.
Fatty acids.
And so naturally, you know that when either it undergo hydrolysis or oxidation reaction or degradation reaction, you can understand that it produce free fatty acids. And that generally, to understand the quality of any oil and fats, we determine the acid value in terms of its aging, rancidity, quality, etc. overall. And between
Yes.
fats and oils, you understand that basically oil is normally a room temperature liquid and fats is
Liquid.
solid.
Solid.
And normally the oil means we understand from the vegetable oil. Okay. Normally we get, and whereas fat normally from in terms of the animals.
Animal.
Okay. Have you got my point?
Yes, sir. Thank you.
So these are the things you should know. Okay.
Yes.
Now, hello, why you are not
Yes, sir.
visible?
So I'm visible.
Madam?
He is visible.
স্যার বলুন।
Okay, জিজ্ঞাসা করার থাকে কোথায় দেখতে
হ্যাঁ
পাচ্ছি না
হ্যাঁ
তো। হ্যাঁ।
হ্যাঁ আচ্ছা okay now tell me DO what is the full form of DO
Dissolved oxygen, ma'am.
dissolve oxygen in where dissolve oxygen in where
In the
air or
sample,
water
ma'am. In the sample. In water. In
the
water sample.
samples
Water sample.
yes the dissolved oxygen in water then why it is needed if the dissolved oxygen is less then what are the problem arises in the aqueous medium
Ma'am, the significance that is more important for the survival of aquatic animals like and organisms, and salinity is also an important factor in determining the amount of oxygen present in our body, and water can hold fresh water can absorb oxygen than salt water.
Then what are the factors affected the DO present in water bodies?
Factors, ma'am? Sorry.
What are the factors affected?
Ma'am, factor is determining the amount of oxygen of a body and water can hold. Like freshwater can absorb more oxygen than salt water.
What are the parameter? What are the factors? What are the parameter affect the dissolved oxygen present in the water bodies? Is it temperature dependent?
Yes, ma'am. Temperature dependence is also a factor. Yes, ma'am.
If temperature is high, then what are the problems? What are the condition of dissolved oxygen?
Ma'am, it reduces.
It reduces. Then what temperature it is maximum?
Ma'am, the temperature will be performed in the lab at 20 degrees
No,
Celsius.
no. At what temperature the dissolved oxygen is maximum? Acha, dissolved oxygen, if you determine the dissolved oxygen in your sample, then what are the name of this the titration?
Ma'am, sorry, what are the
Name, what is called the titration? What is the name of this titration?
name of
That
titration?
means
Ma'am,
the experiment what you have carried out in virtual lab to determine dissolved oxygen. What is that actually? You just
modified
see.
Winker method. Modified
Yes.
Winker method.
Yes. Then what is the titration?
Iodometric.
Iodometric titration. Then modified Winkler's method, why it is needed? What is the difference between Winkler's method and a modified Winkler's method?
Madam, এবার ঠিক আছে. Okay, you can now leave the Viva and you just fill up your Google form as per your roll number within 12:45. Okay, you can
Thank you,
leave.
sir.
Okay.
Thank you, sir.
Krishna. Next, Aritra Krishna.
Aritra Krishna, join.
Yes, sir. Good morning, sir. Good morning, ma'am.
Good afternoon. Okay. Then what is your experiment number 5?
Determination of partition coefficient of acetic acid between water and butanol.
What is the formula of acetic acid?
CH3COOH.
H3COH. It is dibasic acid or monobasic acid?
Monobasic acid.
Monobasic. Is it mineral acid or organic acid?
It's organic acid.
Organic acid. And what are the apparatus you used in this experiment?
The apparatus used in these experiments are burette, burette of 50 ml, conical flask of 250 ml, pipette of 25 ml, pipette pump, volumetric or standard flasks of 250 ml by 1000 ml, funnel, beakers, wash bottle of 500 ml, measuring cylinder, digital balance, separating funnels, graduated pipette, and ring holders.
Graduated pipette and ring holders. Why you take sample 5 ml in organic medium and 10 ml in aqueous medium? For calculation of partition coefficient, is it temperature dependent?
Hello, Arito.
Yes, yes, sir.
What?
Is it temperature dependent?
No, ma'am. No, ma'am.
No. Okay. What's the definition of noneness distribution law? You just
The
give me
Nernst
the
the Nernst distribution law states that at constant temperature, when
no. What is
different
written there? What is written there?
First word
Noneness
is
distribution law states that
at a constant temperature,
that
sorry,
means
so it's
what was the
it depends
question?
on the temperature. It depends on the temperature.
Why? Okay, it's all right. You can leave the Viva and you fill up the Google form and submit within stipulated time 12:45. Okay?
Okay, sir. Okay, sir.
Okay.
next.
Unless those roll number
Present, sir.
25.
Present.
Okay. Unless where is your lab manual? Where is your lab manual? Show your lab manual first.
Okay, sir. Wait a minute. So here.
Okay, just show the where you have written something in the lab manual. You have submitted your assignment first before.
It's difficult to show in mobile.
Okay, fine. Okay, it's all right. All right. What is partition coefficient?
So partition coefficient is a ratio of the organic solution by the aqueous solution.
Okay. You just open your lab manual and see that at the beginning under theory, the what is noneness distribution law?
The Nernst distribution law states that at constant temperature, when defined quantities of a solute are allowed to distribute between two immiscible solvents in contact with each other and exist in same molecular species, then at equilibrium the ratio of the concentration of the solute in two solvent layers is constant.
Okay, fine. Now suppose, provided if the solute molecules are in the same molecular species in both the solvent, which
Yes.
is being a heterogeneous mixture. That's why it is possible to determine the partition coefficient of the given solute. Okay. Now my question is that when they are not in the molecular state or not remain as the same molecular species in the two solvent, suppose during association, what will be the formula, and during dissociation, what will be the formula?
During association, the formula will be C1 by n root over C2, and during dissociation, KD will be C1 by C2 in brackets 1 minus alpha, where alpha is the degree of dissociation.
Where alpha is the degree of dissociation, and
Yes.
when you are finding the square root n, that means the n molecules when they are going to be associate.
Yes, sir.
Okay, okay, very
Yes.
good. Now my next question. So that means these are the limitation. Other than you will have the too much concentrated solution, you will not be able to do, isn't
Yes,
it?
sir. Yes, sir.
Then here, if I ask you that partition coefficient of acetic acid in a heterogeneous mixture of N-butyl alcohol and the water, in which solvent acetic acid is more soluble or more concentration you are getting?
It depends on the solubility product.
In your experiment, you have already written the data also. What I'm asking you that in which solvent here acetic acid is more soluble? In which solvent? How you are determining the partition coefficient? What's the final formula? Look at there, the calculation part.
Yes, sir. Partition coefficient value is 1.27.
And what's the formula did you use?
C ORG by C aqueous.
C organic means key. That is the concentration of
Organic
organic
layer.
element
Yes, yes, sir.
acetic acid in organic solvent by
Yes, sir.
acetic acid in aqueous
Aqueous.
layer.
Yes,
So
sir.
you are getting the value more than 1. So
Yes,
that
sir.
means in which solvent it is more soluble?
In the aqueous layer.
In aqueous layer. Still, that value is in the denominator.
Organic, sir.
Huh?
Organic layer.
Then why you are taking so much time to understand this? Why you are taking so much time to understand that?
So a little
Okay, now
confused
acetic
about that.
acid, for example, in aqueous medium, now what will be its
Yes, sir.
state? Whether it remains as only molecules, only ions, or both molecules and ions. Some dissociation definitely takes place. Otherwise, the acetic acid
Yes,
aqueous
sir.
medium cannot be acidic, isn't it? Are you getting my
Yes, sir.
point? But here, why you are not
Yes, sir.
considering that one C 1 minus alpha? Why you are not considering alpha degree of dissociation? Because you understand the alpha is very less than
Yes, yes, yes,
5%.
sir. Less than 5%.
Clear? Have you
Yes, sir.
understood? Okay.
Yes, sir.
Enough. So you can leave the Viva. Best of luck, and you complete your Google form and submit within stipulated time. Okay. Everything is
Okay, sir.
mentioned. Okay. All the best.
Thank you, sir.
Next, Devdotto.
আমি তো একে অমৃতকে বললাম যে নেক্সট ব্যাচ কিনতে 23 কে বল নেক্সট ব্যাচ কনফার্ম করে দিতে।
হ্যাঁ ইনফর্ম করে দিলে ভালো। আচ্ছা অদিত্য, am I audible? Can you hear me? অদিত্য, ওরা অফ করে চলে গেছে।
রিতেশ তো মানে 23 তে ট্রাইও করলো যে ও হবে বলে।
ঠিক আছে, একটুখানি পজও দরকার, ওরা এসে যাবে, জয়েন করবে। তাহলে দুজন এখনো হয়নি, অগ্নিব জয়েন করবো বলে মনে হয় না, অগ্নিব তো কোনো করেনি, কিন্তু আইএস গুপ্ত এখন জয়েন করলো না তো।
ও তো ল্যাবেও মানে যখন ল্যাব চলতো তখন এরকম করতো।
তাহলে ওটা এক্সাম, ও কিন্তু অগ্নিবোধটা আলাদা,
এত ক্যাজুয়াল।
হ্যাঁ।
দেবদত্ত কিন্তু এই মাঝখানে এই সেশনটার মাঝখানে ঢুকেছিল অনেকক্ষণ, এই কোশ্চেন আনসার শুনবে বলে, তারপরে তো বেরিয়ে গেছে। ওদিকে আবার দেরি হয়ে যাবে না।
এই যে প্রতীক্ষিতা, ওকে ফাইন, তুই জয়েন।
Yes, sir.
Your roll number is 27.
Yes, sir.
Okay. Turn on your video. Okay, fine.
Sir, I've turned it on.
Okay. So, how many virtual lab you have attended in terms of experiment?
Sir, we have done 4 experiments, so I've attended all the labs. Like one I have missed, but others I have attended.
Okay, very good. There is some echo. Why?
Sir, my voice is echoing?
No, my voice is echoing.
No, sir, it's Perfectly audible.
Oh, I don't know. Why?
No, sir, you're audible.
Okay, fine.
আচ্ছা ইকো
My
হচ্ছে
question is
আপনার
that,
ভয়েসটা
huh?
ইকো হচ্ছে একটু
Echo হচ্ছে. Somebody, I don't know. Simultaneously, another person. Hello.
Yes, sir.
Okay, somebody else. I think that only the right now we are talking. We are actually having the one-to-one interaction with Pratikshita. Okay, so nobody else. So please, you just mute and as well as video the other person. Okay. Okay, now now there is no echo. It's fine. Now, regarding the second experiment, what was the objective of the second experiment,
Uh,
Parikshita?
s- Sir, the objective of the second experiment was estimation of chloride ions present in water sample by argenometric precipitation method, Moore method.
Acha, argentometric precipitation method. Okay, fine. Why you are saying argentometric precipitation method?
Because we are titrating the water sample with AgNO3 solution.
Okay. Now, what are the precipitation you generally observe with the chloride content sample and when you are titrating with silver nitrate solution? The
What are
experiment you
the
observe?
precipitation, sir? We have AgCl,
Yes.
silver chloride, and we have Ag2CrO4.
Ag2CR4 from which from where you are getting?
Sir, when we are when silver is reacting with CrO4, when then only we are getting Ag2CrO4 as the red color precipitate.
That means which indicator you are using here?
Uh,
Actually, you are using potassium chromate indicator. Otherwise, you will not be able to understand the end point of the titration.
yes, sir.
That's why you are finding that in the solution there are chloride ions as well as chromate ions, and then the silver ions are reacting with 1:1 proportion.
Yes,
Okay,
sir.
so there will be the simultaneous formation of silver chloride and silver chromate. Okay,
Okay, sir.
and what the end point you find?
Like, sir, at the end of the titration,
Hmm?
sir, at the end we find a stable brownish precipitate of Ag2CrO4.
Actually, the reddish brown color is coming from the Ag2CrO4. Okay,
Yes.
but that because prior to that there will be more turbid solution due to silver chloride. Is it clear?
Yes, sir.
Okay. Do
স্যার
we carry out
স্যার
any blank
স্যার এক
titration here?
মিনিট স্যার দীপন জয়েন করেছে দীপন উইল জয়েন অ্যাট 12:55
Okay,
দীপন লিভ নাও
uh,
দীপন
Deepan,
Okay, ma'am. Okay, ma'am. Okay, ma'am.
hello.
Yes, sir.
Pratikshita, can you hear me?
Yes, sir.
Okay, fine. Now my question is that do you carry out any blank titration here?
In this, yes, we carry.
What is that blank titration? What is the purpose?
Blank titration is basically used to estimate the error that has occurred when we are doing the actual titration.
Okay, that means we have to understand that indicator sensitivity. So in this
Yes.
case, the end point, where do you observe any turbidity?
Yes, sir. The solution is turbid.
Turbid in the sense what? By color change or by some other precipitation?
Sir, after titrating it with AgNO3, we get that light brownish red.
Yes, that is from only silver chromate because it doesn't have any chloride ions. Okay. So naturally, what you will observe with the step 2, the standardization, and what you will observe with the water sample, in case of the blank titration, you will just see the color change. What's the expected value of the Buret reading in the blank titration?
0.7.
Yes, because it is only to understand to observe whether during the experiment whether there will be any error due to the indicator sensitivity. Okay, is it
Okay, sir.
clear?
Yes, sir.
Understandable? Okay.
Yes.
So you can leave the Viva. Best of luck, and you fill up your Google form and submit within stipulated
Sir,
time.
I have submitted the Google form.
Okay, that very good. Fine.
Thank you, sir.
All the best.
Next, Shoham Ghosh, 28.
Soham Ghosh.
Yes, sir. Sir, am I audible?
Yes.
Yes, you are audible.
Shoham, tell me the preparation of primary standard solution. What is the
You just
procedure?
turn on your video, Soham.
Sir, I have turned on my video.
Then why you
You
are
are
not
too
visible?
close to the camera.
You are not visible
Just
anyway.
too close to the camera.
Ma'am, is it okay now?
Set it properly.
I am unable to see you.
Make a distance. Make a
Ma'am, is it
distance.
okay now?
Little more distance.
Ma'am, is it now okay?
Yes.
But I don't know. I am unable to see you right now. Okay, madam, continue.
Okay, Shoham,
Yes, ma'am.
tell me what is the procedure for preparation of primary standard solution?
So, a primary standard solution is a solution whose strength is already known. So, before standardizing a secondary solution with the
My question is what is the procedure for preparation of primary standard solution?
yes, ma'am. First, we determine the normality of the primary solution, the primary standard solution that we have to use. Then, according to the normality, we prepare the equivalent mass of the chemical, the compound, and then according to the normality, we take that much amount of reagent in that particular ml of solvent to prepare the primary standard solution of the given normality.
What is the definition of normal solution?
Amount of gram equivalent in 1 liter of solvent.
Solvent.
1 liter of solution.
1 liter of solution. Which type of balance you use?
We use the electrical balance, the balance where the decimal points of the weights are shown.
Electrical, electronics,
Yes, ma'am.
electronic balance. Then what is the difference between primary standard and secondary standard?
A primary standard solution is a solution whose strength is known, and the concentration of primary standard solution do not changes its concentration with time. But a secondary standard solution, the concentration of the secondary standard solution changes with time, so it is not fixed. So before using a secondary standard solution, just before the experiments, you have to standardize it with a primary standard solution.
Okay. Tell me three primary standard chemicals which you used.
Oxalic acid solution, sodium carbonate solution,
And another one?
K2Cr2O7 solution. Potassium.
Soham Ghosh, can you answer? Can you say that whether what's the molecular formula of mode salt?
More salt? No, sir, I don't remember.
Whether the mode salt can be used as a primary standard solution or secondary standard solution? Okay, you are unable to say the molecular formula. Okay, fine. And what's the molecular formula of hypo?
Sir, Na2SO3.5H2.
কি হলো Na2 তারপরে after that
Na2
Sir, Na2S2O3.5H2O.
Okay, very good. Now whether it will be a secondary standard solution or primary standard solution?
No, sir, it is a secondary standard solution.
Okay, generally how do we determine its equivalent mass?
Sir, so initially we take the molar mass, then
how many electrons take part per molecule of this?
sir, 6.
6. You will verify that how you determine the equivalent mass of sodium thiosulfate. Okay.
Okay, sir.
And how do we determine equivalent mass of potassium dichromate?
Sir, by the oxidation and reduction, the number of electrons that is gained or lose in that way.
Okay, so that's I'm asking you that how many electrons generally involved?
Sir, 2.
No. So that also should verify. It is a very most common reaction, important reaction. Okay, best of luck. You can leave the Viva, and have you not submitted yet the Google form? You submit it within stipulated time. Okay.
I have submitted Google form.
Okay, that's good. That's good. That's good then.
স্যার দেবদত্ত তো জয়েন করেছে।
They will the last take on number next again home. Simoy, roll number 29.
Yes, sir. Am I audible?
Yes, you are audible. Okay. Okay, you are audible and visible as well. Okay, fine. If I ask you what's the first experiment, what will be your reply?
It is the determination of acid value of vegetable fatty oil.
Okay, very good. Now, what do you understand by fatty oils? First, you have just a minute. First, you will answer the what is fatty oil, and second, that what is acid value. Okay, how do we define acid value? Okay, now carry on.
Fatty oil. It is it is a complex made by carboxylic acid.
My question is that suppose you are determining acid value of fatty oil or the rather simply fats or oil, for example. Okay. Now, what do you understand by fats and oil, first of all? And secondly, how do you define this acid value or acid number? What is that?
Sir, first I say what is fatty oil.
Yes. What is fats and oils?
It is a carboxylic acid which are long aliphatic chain which is saturated or unsaturated.
That is possible, saturated or unsaturated, no doubt. Actually, what is that? Because at the very beginning itself, in the fats and oil are only the long chain fatty acid, for example, unsaturated or saturated. Then what's the need of acid value determination of that fats and oil finally?
This acid value indicates the amount of fatty acid present in the oil.
Yes.
Present in the oil. And it is defined as a number of milligram of potassium hydroxide required to neutralize the free acid present in 1 gram of the fatty oil.
Okay, fine. Now, again, you didn't say the fats and oil. Then, what do you understand by rancidity?
Rancidity. Rancidity. It is a condition which the substance with oil and fats gets oxidized when they are exposed in the air.
Okay, very good. One of the answer. Now the question, because of that, what happens?
Um,
What's the
the
result?
for rancidity,
Hmm.
uh, it's change in chemical order and
You can see you are defining that in fats and oil, you are determining the in terms of the acid value or acid number. That is the what is the amount of free fatty acid present, isn't it?
okay.
My
Yes,
question
sir.
is, where does it come from? Basically, your answer would be that oil and fats are nothing but triglyceride ester of long chain fatty acid. Okay, and that
Right.
you are saying because of hydrolysis, because of oxidation, because of so different due to different reasons undergo degradation and it produce free fatty acid. Because you know the ester generally forms why? I mean, how? It is a combination of alcohol, OH group, and carboxylic acid.
Carboxylic acid.
And again, you know the ester on hydrolysis it gives back fatty acid, or ester on degradation it gives back, or hydrolysis it gives back alcohol and acid.
Acid.
So that's why here you are fine determining actually that is from triglyceride ester of long chain fatty acid in oils and fats. When undergo degradation, it can produce free fatty acid, and that means which indicate the quality of that fats and oils. Okay, is it clear?
Okay.
Okay, fine. Now, which indicator do you use?
Phenolphthalein.
Phenolphthalein. What's its pH range?
8.2 to 10.
Okay, very good. Now my question is that suppose in case of this acid value determination titration, what is your observation? The color change by using phenolphthalein indicator. When does it happen?
It turns to pink
When?
when KOH solution is added.
Whether at the very beginning itself.
No, at the end point.
Why at the end point? Because that the pH, that means by extra drop of KOE solution after the neutralization point, that solution becomes alkaline, the pH
Alkaline
goes above 8, so that's why
and
it shows the pink color,
pink
isn't
color.
it?
Yes.
Understandable?
Yes.
Okay. You can leave the lab, leave the Viva, best of luck. And you just, have you not submitted your Google form? You submit it within
Yes, sir.
12
They
hours.
submitted. Thank
Okay,
you, sir.
okay, best of luck. Good. Next, the doctor. The doctor.
Sir, am I visible?
The doctor, why you
Yes.
didn't
Yes,
join on
you are
time?
visible.
You had
Hello,
joined
sir.
earlier, then you left in between.
Sir, actually, my roll number at that time it was something. I mean, I had some misconception of the roll number being 25 or 26, so I had to rejoin with the second meeting.
Your semester is just complete almost,
I
and you
know,
are saying that still confusion with the roll number. Okay, madam will ask you question. Okay.
Okay. Now, what is your the third experiment?
sorry, ma'am, I'm not clearly audible. Can you speak a little louder?
Third experiment. What is the object of your third experiment?
The objective is determination of determination of dissolved oxygen present in water sample using iodometric titration.
Using iodometric titration.
Yes.
Then what is the procedure for iodometric titration? What is the meaning of iodometric titration?
Iodometric titration is the titration where the presence of the appearance and disappearance of iodine ion indicates the endpoint. And
Appearance and disappearance means?
sorry, ma'am.
Appearance and disappearance. What is the meaning of appearance and disappearance?
Ma'am, elementary iodine during the reaction, the elementary iodine, so, I mean, it's visible as well as sometimes it due to the
Formation.
dissolution, it is not.
Formation
Yes.
of elementary iodine, and after that it is,
Disappearance, it indicates the it's used for the indication of endpoint.
that means it is a redox reaction or not?
It's a redox reaction.
It's a redox reaction.
Yes, ma'am, it's a redox reaction.
Redox reaction. Then if it is a redox reaction, then during titration, what type of indicator you use?
Ma'am, once more, please. I didn't. The voice is cracking. Hello.
Hello, what type of indicator you use during this titration?
K2Cr2O7.
DO, experiment DO you used K2CR207.
Yes, ma'am.
In which experiment you are using K2Cr207, Debrotto?
Ma'am, sir, experiment 3, where we determine the dissolved oxygen in water sample by iodometric titration.
K2Cr207, you just open your lab manual immediately, check. For what purpose K2Cr207 we use there?
Sorry, sir, it's start solution is used as the indicator.
K2Cr207, that is a very important
Oxidizing agent.
inorganic substance. Generally, we use in this case as a primary standard solution. Okay.
Sorry, sir, it's starch solution.
Starch solution, what type of indicator, organic or inorganic?
Starch, it's an organic indicator.
What is the color
It's
during
blue black.
titration?
Hello, yes, ma'am.
What is the color during titration if you see?
Dark blue black. And after
Dark.
the titration, it becomes light green at the end point.
Who gives the light green color?
Ma'am, at the end point, it becomes light green.
But who gives the light green color? Starch or indicator?
Madam asking you because of what you are getting transparent clear solution, but light green stone. Light green stone, where does it come from?
Sodium thiosulfate.
For sodium thiosulfate. Sodium thiosulfate always is colorless.
Okay, sir. Okay,
Okay, it's fine. You can leave the Viva and you just submit your Google form within stipulated time. Okay, that's all.
স্যার রোল নাম্বারটা কত ছিল?
Huh?
রোল নাম্বার?
Roll number
26. 26.
Okay, okay.
Ayush Gupta.
Yes, sir. Am I audible? Hello?
Yes.
Yes.
Okay, ma'am.
Good afternoon.
Good
Ayush.
afternoon, sir. Good afternoon, ma'am.
Then, which experiments you do very well?
Yes, ma'am. I can hear you.
Are you prepared?
Ma'am, can you repeat?
Are you prepared?
Yes, ma'am, more or less.
More or less.
Okay.
Then, which experiment? If you prepared very well.
Experiment 1, maybe.
Experiment 1. Okay.
Yes,
Then, in experiment 1, what are chemicals you used?
First, for the primary standard solution, I guess we use oxalic acid solution,
Which number?
N by 10.
N by 10. What is the required amount?
Required amount, ma'am, it is maybe 2.2 grams or
2.2 grams.
ma'am, for the solution, ma'am, it's I guess 100 and ma'am, we have to say like which is mentioned in the manual, which was mentioned in the manual, right?
Then see the manual and tell me what is the
Uh,
required amount.
125 grams, I guess. 125 grams, ma'am.
125 grams. In what volume?
And what value?
What volume?
Ma'am, Sorry, it's 0.63 grams.
0.63, and the volume
Grams.
is, and the
Volume.
volume of our solution is
Volume of the
solution, primary standard solution. What volume you prepared?
that I don't
0.63,
know, ma'am.
what volume?
I don't know that, ma'am.
And what are the apparatus you use?
Apparatus, ma'am, will need a burette of
The rate of what volume?
50 ml
Then
and a conical flask 250 ml and a pipette of 20 25 ml 25 ml
mm-hmm.
and pipette pump and standard flasks, I guess. Yes, ma'am. Volumetric standard flasks.
Volumetric standard flux, what volume you use?
250 ml or 1 liter, 1000 ml.
250 ml and 1 liter.
No, 1000 ml.
Then 0.63 is in what volume? 250 ml or 1000 ml?
Uh, I guess it is 1000, ma'am. Because it's a standard solution, so I guess I will need. Yes, ma'am. 1000 ml. 1000 ml.
Okay. Now, which indicator you used?
Uh, phenol Phenolphthalein. Uh,
Phenolphthalein indicator. What type of indicator?
mm, uh, that I don't know, ma'am.
Okay, it's all right. ঠিক আছে. Okay, you can leave the Viva, and have you not submitted your Google form, you submit it immediately. Okay.
Yes, I have submitted the Google form.
Okay.
Thank
Okay.
you, sir. Thank you, ma'am.
তাহলে ম্যাডাম আমাদের তো এখন একটা ভাইভাটা কমপ্লিট হয়ে গেল, ফার্স্ট টাইম ভাইভাটা কেমন ঠিক আছে?
আচ্ছা দীপন বাকি আছে।
হ্যাঁ
না স্যার আমি
দীপন 31
31 একজন বাকি আছে।
হ্যাঁ দীপন বাকি আছে, দীপন ওকে, দীপন বাকি আছে, রাইট রাইট রাইট।
দীপন turn on your video.
হুম
ওকে
Where is your uniform?
ম্যাম আমি ইউনিফর্মটা এখনো কিনতে পারিনি, স্যারকেও বলেছিলাম, তো স্যার বললো তুমি ফর্মাল ড্রেস পরে বসতে পারো।
Okay, but discipline is discipline. Remember it.
ইয়েস ম্যাম, ইয়েস ম্যাম, ইয়েস ম্যাম, সরি ম্যাম।
Okay, then what is your second experiment?
Yes, ma'am.
What
What
is
is
your
the second experiment? Ma'am,
Ah,
estimation of fluid ions present in water sample by argentometric precipitation titration mode method.
okay. Okay, then silver nitrate is primary standard or secondary standard?
Ma'am, primary standard.
Then why you prepare sodium chloride solution?
Why? Sodium.
What is the permissible limit of sodium chloride? What is the permissible limit of chloride down in your drinking water?
Sorry.
Did you write the under evaluation the question answer? You just check there, lab manual, what's the answer you have written there?
Okay,
What should
sir.
be the permissible level of chloride contained in the drinking water? That question is there.
Sir, 250 mg per liter.
Means up to that. Okay. The,
Okay,
the less the value, it is better. Is it clear?
Okay, sir. Okay, sir. Okay.
Okay, sir.
What is the optimum pH level of Morse method of chloride determination?
Sir, 6.5 to 9.
6.5 to 9.
Yes, sir.
Why?
Because
Why
sir,
you
at
are
a
saying this?
higher pH, because sir, at a higher pH, silverness may be removed by the hydroxide ions
Actually,
at loss.
ideally, it should be, I'm telling you, between 7 to 8. Okay.
Okay.
Okay,
Okay.
6.5 to 9 to some extent understandable. But ideally,
Okay.
it should be between 7 to 8. Now you
Okay, sir.
answer it.
Sir, because at higher sir pH, silverness may be removed by the partition of hydroxide ions, and at loss pH, sir, fluoride ions may be removed by an acid-base reaction to form hydrogen chromate ions. So, sir, that is the reason I said the pH 6.5 to 9.
Okay, fine. Can you see that what's the solubility product of silver chloride and what's the solubility product of silver chromate?
Sir,
You will find, I'm telling you, I'm giving you a hint. The solubility product in case of silver product, chromate is less in the order of 10 to the power minus 12. Whereas in
okay.
case of the silver chloride is in the order of 10 to the minus 10. Now the next question, which one is more soluble?
Sir, Ag2CrO4.
Yes. So that's why what you are finding, what's the principle here of the experiment? You are using potassium chromate indicator.
Yes,
Okay,
yes.
so whenever you are
Yes, sir.
adding supernatant solution from the burette, you are finding there will be simultaneous formation of the silver chloride as well as silver chromate, isn't it?
Okay. Okay, sir.
Then what do you find, what do you generally observe, what do you are supposed to observe actually, that each time the some red color comes and then disappears
Yes,
because
sir. Yes, sir.
due to the chloride ion, the silver ion will preferably react with the chloride ion first. Okay.
Yes. Yes, sir.
Then finally, why you are getting the end point that reddish brown? Why you are getting the reddish brown finally end point? Can you explain? Can you say in one or two words or sentence maximum? I am telling you finally that once all the chloride ions are consumed by
Yes,
equivalent
sir.
amount of silver ions, then when there is no chloride ion is left, now due to the presence of free chromate ion, now Ag plus
Yes.
is now reacting and producing silver chromate. So that's why in white liquid solution you are getting that brick reddish color, the reddish brown finally. Okay.
Yes. Yes,
That's
sir.
all for you, and best of luck. Have a good day. And have you not submitted your Google form? You submit it
No, sir.
immediately.
I submitted, sir. I
Okay,
submitted.
that's all. That's very good then.
Okay.
Then you can leave the Viber.
Thank you.
Oh, best of luck.
Thank you.
স্যার আমাদের ফার্স্ট হাফ কমপ্লিট হলো।
ফার্স্টে কমপ্লিট হয়ে গেল।
ঠিক আছে, তাহলে
হ্যাঁ স্যার
সেকেন্ড
দুজন বাকি রইলো।
দুজন বাকি রয়েছে মানে
অগ্নিভোগস্থ
অগ্নিভোগ তো এমনি জয়েন করবে না।
নেই, হ্যাঁ, আর
অগ্নিভোগ
আইস
তো
দত্ত।
এমনি জয়েন করবে না, কিন্তু এর কি হলো ব্যাপারটা বুঝতে পারলাম না। ওই কি বলে
আইস দত্ত।
আয়েস দত্ত, হ্যাঁ ও আসেনি। আমাদের তো কিছু করার নেই এখানে, ঠিক আছে?
হ্যাঁ হ্যাঁ
ঠিক
স্যার
আছে,
দুটো থেকে তাহলে সেকেন্ডটা
আবার
শুরু
দুটো
হবে
থেকে
তো?
শুরু হবে। ঠিক আছে, আমি ওদের আবার রেডি
ঠিক
করে রেখেছি। ঠিক আছে,
ঠিক আছে।
so we can now leave, okay?
হুম।